Now let me show you. Let me execute. So it will return me extracted data. So here I've given the path. Okay, so it should be data. Okay, data directory. Now let me show you. So if I execute, now see, it is extracting all the information from the PDF itself, and it is having almost 700 actually pages. So it will take some time. So let's wait. So guys, as you can see, my extraction is done. Now if I show you the extracted data, see, this is the entire extracted data actually we got. Okay, from all the pages, it will show you the data. Now let me comment it as of now. Now what I have to do, I have to perform the chunking operation, because you remember, see the architecture, I have extracted the documents. Now I have to perform the chunking operation. Okay, and to perform the chunking operation, I will be using recursive text splitter. So with that, I have created another function here. So split the data into text chunks. So it will take the extracted data, it will perform the chunking operation, you can see. So here is the code. So chunk size is 500 and chunk overlay is 20 I have given, and it will perform the chunking operation and it will give you the chunk results. Okay, now let me show you. So now if I execute the function and if I show you the length of the text chunks, now see, you got 7020 chunks here, guys. 7020 chunks you got. Just try to see how much data actually you have in the PDF. Okay, and this is enough information to create one medical chatbot. I believe that. Fine. That's why I have taken this big data, guys. Now see, this is the entire chunks actually I got. Now what I have to do, I have to use one embedding model to like perform the vector embedding, and this embedding I'll be storing to the knowledge base, that means inside my Pinecone vector database. Okay, so now let's download one embedding model from the Hugging Face. Okay, so here is the function I have written, guys. Download Hugging Face embedding model. Now for this, I need to import this package. First of all, let me import. So this is the package, guys, Hugging Face embedding. I'm importing from the LangChain embedding. Okay, now let me execute. Now this function will automatically download one embedding model. See, this is the embedding model I want to use. Let me show you this embedding model. So this is present inside Hugging Face. So the name of the model is All Mini LM L6V2. So this is one actually embedding model, and it will give you vector dimensional 384 4-dimensional vector actually it will return you. And this dimension you need because whenever you are using Pinecone vector database, you need to also mention the dimension of the vector, like what is your vector dimension. Whenever you are creating the cluster, now whenever you are creating the index, that time you have to mention this dimension. So that's why always try to remember, whenever you are using Pinecone vector database, try to see what kinds of, let's say, embedding model you are using, and that embedding model returns what kinds of dimensional vector. Just try to see the documentation, you will also already get it. Fine. Now let me download the embedding model. So let me execute this function. I'll download the embedding model. See, it is downloading from the Hugging Face hub, so it will take some time. Let's wait. So guys, you can see my model has downloaded. Okay, now let's test the model, whether it is able to convert my sentence to vector embedding or not. So for this, I've given one sentence here, hello world, and there is a function called embed query. So it will automatically give you the vector embedding, and I'm also checking the length, whether it is giving me 384 dimensional vector or not. Now see, if I execute the program, now see, length is 384, and if you want to see the vector, see, this is the complete vector actually you got. Okay, I hope it is clear. Now let me comment this line as of now. Got it. Now what I have to do, guys, I have to initialize my Pinecone. Inside Pinecone, actually I have to store, these are the vector. Okay, the complete vector actually I'll be generating from my text chunks. So for this, let's open up my Pinecone. So if you want to open up the Pinecone, just write pinecone.io. So this is the website, and make sure you created one account, guys. Just do the sign up operation with your email address. You can create an account. So for me, I already have one account. Let me log in. So guys, as you can see, this is my Pinecone website. Okay, this is the interface of the Pinecone, and this is one of the amazing vector database provider, guys. You will be loving a lot. Even I personally like it. So here, what I have to do, guys, I have to create a index. That means I have to create a cluster. In that cluster, actually, I'll be saving all of my vector. They have also given the quick start, like how we can set up the Pinecone, how we can, let's say, store the data. See, all the code example they have also given. Okay, so we'll be following the same approach to store our embeddings to the Pinecone. But before that, you have to collect one API key. So how to collect the API key? Left hand side, you can see one API key option is there. Just try to click here. For me, I already created one API key. If you don't have, just try to create an API key. Just give the name. Let's say I'll give test, or you can give any name. Let's create the API key. Okay, so this is the API key. Now just try to copy the API key, guys, and try to mention inside this .env file. So I'll open the .env file. So let me paste it here, and make sure you are giving one key name here. That means this is your Pinecone API key. Okay, that's it. And make sure you are writing this thing in a string. Got it? Now let me open up my trials.ipynb. Now what I will do, I'll just create a cluster here. So let me go back to the database. And don't share this key with anyone, guys. Otherwise, they will be also able to access your account. Okay. I'll be removing it after this recording. So for you, no need to share with anyone. Now inside Pinecone, either you can manually create the index. Let's say you can click here, create index. Let's create one index. Let's say I want to create, let's say anything. You can give test. Now dimension, let's say 384. The same dimension I will give here. The dimension actually I'm getting. Cosine matrix, just keep it. You can also select different metrics, like what kinds of, let's say, similarity metrics it will apply whenever it will do the semantic search operation. I want to use cosine score. Now just keep it everything as default. You don't need to change the provider. See, AWS is the free one. If you're, let's say, sign up for the first time, you can create 1 to 2 cluster here with the help of AWS cloud provider. But if you want to take their premium subscription, that means you want to create a multiple cluster. If you want to take some more space, you can see, if you're using free plan, you will get 2 GB storage here. But if you have more than 2 GB data, that time you have to take the premium subscription. Okay. That time actually what you have to do, you have to take their plan, subscription plan. Let's say if I take this one, Google Cloud. Now see the price plan. See, this is the price plan actually they have. So with respect to that, you can also purchase their, let's say, machine. Okay. But as of now, I'll be using the free services only. I don't need the, let's say, premium subscription of the Pinecone. But if you are creating the actual project, if you need more spaces, that time you can do it. So I'll be selecting the AWS cloud provider. And region, just keep it everything as default. Only just need to give the name. Okay, name and the dimension. That's it. 384. Okay. Now let's create the index. So this is the manual approach to create the index, guys. Okay. This is the manual approach. See, this index is getting created. It is getting initialized. And once it is initialized, see, it would be connected. Okay. See, it is now connected. Okay. Now, if you want to connect it, you can execute this Python code and you can insert your data. All the config code they have already given. Okay. But I don't want to create this index manually. I want to create through the Python code. So let me delete it. So if you want to delete it, just click here and try to delete the index. So you have to give the name. Okay, I'll be deleting because I will be creating through the Python code. And how to create through the Python code, guys? I think they have already given one starter code. Remember? So here you can give the index name, like which index you want to create, and create index dimension. You can give here metrics, serverless, AWS, region. Okay, everything you can pass here. So now let's use this approach to create the index. So what I'll do, I'll go back to my VS Code, and I already prepared this code for you. So let me show you. So this is the code. Only you just need to change the API key. So let me change the API key. The API key I have collected here. Let me copy and let me change it here. Or I think I can read it from the environment only. So what I can do, I can import the environment. Just a minute. So let's import. So from .env, import load env. Okay. Then I will load the env. Now simply I'll get this Pinecone API key from my environment, and here it will save inside this variable. Now this variable actually I'll pass here. Okay, so nobody won't be able to see my API key that time. So this is the best approach, guys. You can also follow. Now you can give the index name. Let's say I'll give medical bot. Let's say this is my index name. And here you have to give the dimension. So make sure which embedding model you are using and what is the dimension size. 384. That means it's fine. 384. Keep everything as default: cosine, serverless, AWS, US East 1. Okay, no need to change anything because we are using free cluster here. Fine. Now, once you will execute this code, you will see that your index would be automatically created in the Pinecone. Let me show you. So if I execute this code now, see what will happen. So guys, execution is done. Now if I get back to my Pinecone and if I refresh it here, see, medical chatbot should be created here. Let me show you. See, medical chatbot is created. Automatically it has created. And now it is active and running. Okay. Now what I can do, I can convert our, let's say, chunks to the vector embedding, and I can store inside the Pinecone vector database. So for this, what I can do. So for this, first of all, set this Pinecone API key as your environment variable. Because whenever we'll be storing the, let's say, data to the Pinecone, so Pinecone internally looks for this API key inside the environment variable. Okay, so for this we are using operating system environ. Okay, environ, and this is the key name, guys, I'm giving, and I'm setting my Pinecone API key. Okay, whatever API key I'm loading from my .env file, so it will set inside my environment variable right now. Okay, so whenever I'll execute my Pinecone code, I don't need to again and again pass it. Okay, again and again, I don't need to pass it here. This is the advantage. Now see, to store the vector embedding, this is the code snippet you have to execute, guys. So you can see this is the code snippet. Let me comment here. Now I'm importing LangChain Pinecone import Pinecone vector store. Okay. Now inside Pinecone vector store, you have one function called from documents. So first of all, you have to give the documents. That means my text chunks. The text chunks I have created. Remember. So this is the text chunks I have created. Okay. So this text chunks you have to give. Then you have to give the index name. So what is the index name I have given, guys? I think remember this is the index name. That means this index name it is already created. That means inside this index it will store the data. Got it? So make sure you check this at the variable. Now I need to give the embedding model. So I think remember we downloaded one embedding model. Okay, from the Hugging Face app. Got it? So these three parameters you have to pass here. Now see, if I execute this line, it will convert all of my data to the vector embedding and will store to the Pinecone vector database. And how many chunks I got, guys? I think remember I got 7020 chunks. That means 7020 chunks vector would be stored inside my Pinecone. So it will take some time, guys. Let's wait. After executing this code, I'll pause the video, and once this vector will get stored in my Pinecone, I will come back again. See, let me show you. If I go to my Pinecone right now, and if you refresh the page here, see all of the vector would be stored here. Even you can also see the count. Let me show you. See, as of now, 864, let's say, chunks has been added. Now see, 1000. Now see, you can also see the visualization of the vector. It's amazing, right? So whenever you used to use local vector DB, it was not possible to visualize our vector, but here it is possible. You can see. You can also see the score. That means semantic score. Like what is the score between this vector, and this vector? Got it? This is one amazing visualization, guys. You will get in the Pinecone. And see, this is the entire vector representation of this entire sentence. Okay, entire text. Okay, and even it is also showing the page number, in which page it is extracting the data, and what is the PDF name as well. Okay, every information you can see here. Even you can also perform the query operation. That means the way you perform the SQL query, you can also perform the query operation here manually. Everything is possible, but everything will be doing through the Python code. I'm not going to use the manual approach here. Now see the vector count, guys. So 4120 vector has been stored. Now let's wait. Once it has saved all of my vector, I'll come back and I'll show you. So guys, as you can see, my execution is completed. Now if I get back to my Pinecone and if I refresh, see all of the vector it has stored here, like more than 7000 vector it has stored inside my Pinecone index. Okay, now what I can do, I can use this index as my knowledge base. That means we'll be connecting my large language model with this knowledge base, and we'll be asking the query, and it will do the semantic search operation here. Okay, this is the idea. Now let's get back to my code editor. Now see, I already created the index and I already stored my vector there. Now I want to load my existing index. If you want to load the existing index, what you can do, you can use this code snippet. Okay, see, again I'm importing Pinecone vector store from LangChain Pinecone, and there is another function called from existing index. Okay, from existing index, you have to give the index name. So the index name, I've given the same index name, and you have to pass the embedding model. The embedding model you have downloaded. Now see, if you execute this line of code, it will load the index. That means whatever index you have created and all the vector, actually it will load, and it will give you the doc source object. Okay, this is an object, doc source object. Now you can also perform the retrieve operation here. That means you can perform the similarity search operation here. Let me show you one example. There's a doc source as retriever, search type similarity, search keyword 3. That means it will give you 3 relevant answer. Let me show you. So if I initialize my retriever object, and now I will ask one question here. So this is my medical data. I will ask, let's say, what is acne? Okay, acne. So I think you know, inside this PDF, I'm having acne related disease also. Let me show you. So if I press Ctrl F, acne. So guys, as you can see, this is the acne disease. What is acne and all? So you can see acne and acne related actually treatment. Okay, medicine. They have suggested each and everything. So I'll asking one question here. So what is acne? So it should give me the relevant answer. Okay, for the acne from my knowledge base. Now let me execute and let me show you. Now see, if I show you this retrieved docs, it will give you 3 results actually. 3 results. Even it is also showing the source, okay, from where it has referred. Now see, different actually acne related response it has given me. Okay, because I have set search keyword is equal to 3, it will only give me 3 response. Okay, but I don't need this kinds of output. I need a complete let's say definition. Okay, what is acne? Got it? So for this, what I have to do, guys, I think you remember I have to integrate my large language model. That means here we'll be working on user will give the answer query. This query will go to knowledge base. Knowledge base will give the rank results. I'll be using the large language model. So LLM will process this rank results as well as the query, and it will give me the correct response. Okay. So for this, let's initialize my model. So I already told you we'll be using OpenAI model. So OpenAI. So let's initialize my OpenAI model. And I think you already know what is temperature and max token. So it is giving me one error. Okay, it is giving me error because I haven't set my OpenAI API key. So let's set the OpenAI API key. I'll open up my environment. So here is my API key, guys. So make sure you create one API key and just try to paste here. And similar wise, I also need to set this API key as in my environment variable. Okay. So let me execute this code. So here what I can do, I can duplicate this line and here I can write OpenAI API key. So it will also give me my OpenAI API key. Then here, whenever I'm setting as an environment, here I can also change OpenAI API key, OpenAI API key. Okay. Now let's set this one. Okay, string expected none time. Okay, so I think I have to load it again, then I have to execute. Now it should work. Now it is working fine. Now if I get back here, now if I initialize it, it should work. See, successfully I have initialized my large language model. Now I have to create the complete chain. For this, let's import some library. Previously I showed you now how to create the RAG application. There I think you remember we were importing this library, create retrieval chain, create stub document chain, okay, create prompt chat prompt template. Okay, everything I already showed you there. So we are importing the same code here. Now this is going to be my system prompt. So here I want to give this prompt in my language model, okay, large language model. Now I'm going to create the complete prompt template. You can see this is the system prompt, and whatever input user will give, that means the input actually I have given, it will come here and it will give you the complete output. Now let me initialize. Now let's create my chain. So create stuff chain. Inside that you have to give the LLM as well as the prompt, and whatever object you will get inside create retrieval chain, you have to pass it as well as the retriever. That means your vector store. The vector store you created, okay, retriever object. Now let's initialize my chain. Now let's ask the question. So here I will give what is acne. Okay, what is acne? Sorry, acne. Now see the response, guys. See, acne is a common skin disease characterized by pimples on the face, chest and back. It is caused by clogged pores and become inflamed due to the oil, dead skin cells, okay, and bacteria treatment and so on. See, that means it has given me the correct response. If you open the PDF now, this book right now, and if you read it here, you'll see that it has given me the correct response. Now see, if I giving any other question which is not relevant about the PDF, what will happen? See, now see, if I give any other, let's say question, let's say I have given what is stats, that means what is statistics, it is telling me I don't know, because here I have given the prompt now. So if you're not getting the context, that means here this question I'm asking, this is out of context. That means the data I have given to my model, okay, the knowledge base I have given to my model, so this information is not available here. So that's why it is telling I don't know. Okay, so this is the complete custom system we have created, like custom chatbot we have created, which is only referring our custom data. Okay, I hope it is clear. So guys, this is the actually entire demo. Like that's how actually we'll be implementing the entire application. Now you can ask any kinds of question. Let me show you. So you can take any other disease. Let me show you. Or let's take any other disease. Okay, let's take this disease actually. This one. I'll copy and I'll come back here. Then I'll ask here. Now let's see. See, it is giving you the response. Growth hormones resulting the abnormal growth. Okay. See, that means this is the correct response actually I'm getting. Now if you see the image, so the same thing. Okay. So you can see this disease is a abnormal releases particular chemical from the so blah blah blah. Okay, so you can read it. So that means we are getting the correct response. Fine. Now let's try to convert this project as our end-to-end implementation right now. That means we'll be also implementing the UI. But before that, I have to first of all create the modular coding. Okay. So what I'll do, guys, I will first of all open up my helper.py. Inside helper.py, whatever, let's say, utility related code I have written, let's say loading the data, then creating the chunks, then loading the embedding model, all the function I will move inside this helper.py. So let me open. So inside that, I'm going to import all of the library. See, I just copy pasted the code from my notebook only. If you open the notebook, the same code actually I'm copy pasting. And why it is giving the error? Because below you can see I have to select my environment, the correct environment. Let's say medical bot. Now this error will be disappeared. Now see all the function I'll just copy paste here. All the three function I have written now. My load PDF, then this one text split, and this one my load embedding model. So here I kept all the function, you can see, because I want to import from here. So these are the function I don't want to create inside my endpoint. Otherwise my code base would be like messy, right? That's why I am creating inside this particular file. Now let me save, and inside prompt, actually what I will do, I'll give the system prompt, whatever prompt actually I have written. So here is the prompt, guys. I think you remember. I'll copy the prompt, and inside prompt.py I'm going to mention it here. Okay, so from here I'm going to open the prompt. Let's say in future you want to change the prompt, you want to give any other prompt, you can open this prompt.py, you can change here, it will reflect in your code. Okay, no need to open your actual code implementation that time. Fine, so let me close this at the tab. As of now it's not required. Now yeah, so helper is fine. Now what I will do, I will create another file here, and I will name it as store underscore index .py. Okay, .py. Why? Because let's say you want to update this book, let's say you want to add some more information. That time again you have to store all the embeddings to the knowledge base, that means inside your Pinecone, yes or no, right? And to store it, I again need to execute one like endpoint, that means store underscore index.py. Whenever you will execute it, it will load the new information and it will store to the vector database again. Fine. So for this, what I will do, I'll prepare this one. So see, whatever code I have written now here, that means I extracted my let's say documents, I created the chunks, downloaded the embedding model. After that, I pushed everything to my vector database. Okay, see all the let's say vector database code I have written, everything I need to write inside that one. So let me import all of the library. So you can see I'm importing from src helper, that means from src helper. So inside helper I'm having three functions: load PDF, then text split, and download face embeddings. Okay, see I'm importing all of them, Hugging Face embedding. Okay, then I'm also importing Pinecone, then Pinecone vector store, then load env and operating system. First of all, I have to set my environment variable, that means my credential. Okay, OpenAI, sorry, Pinecone API credential. Then I will be loading my data, extracting the data, creating the chunks, then I'll be loading the embedding model. See, load file, that means I'm loading the data, so I have to give the data location. So this is my data location. Then text splitter will run, then download the embedding model. Okay, then after that I will initialize my Pinecone code base. The same code, guys. If you open the Jupyter notebook file, the same code. See, Pinecone initialization, it will create the medical chatbot. Okay, medical bot, that means this bot it will create. Okay, then it will actually create the index, then it will store the embeddings. Okay, so at the very first time you have to execute this line, guys. Okay, very first time you have to execute this file. Then whatever actually, let's say data you are having, it will do the vector conversion, that means embedding conversion, then it will store to the vector database. Okay, now what I'll do, I'll just delete my previous embeddings, whatever I created. This cluster I want to delete it, because now I'm doing the modular coding now. So I'll be executing everything from my modular coding itself. Now let me remove it. Now see, it will delete it. After some times you will see that it won't be visible here. Now see, make sure, guys, before launching your application, first of all, you need to execute this store index.py. Make sure this index should be created. Otherwise you won't be able to do the query operation, right? So at the very first time you have to execute this store index.py. Okay, then you will be launching your application, that means app.py. And this one you have to only execute one time, not multiple time. Multiple time when you will be executing, whenever you will update the data. Let's say you want to add any other data, one more PDF, that time you will be executing this file. Okay, otherwise just keep it as default. That's it. Now let me save. Now I think this is deleted. Now see, there is nothing. Now what I will do, let me show you how it will create everything. So I'll open up my terminal. Let me clear. Now let's execute this store index.py. Python store index.py. Now let's execute. See, again, it will perform all the operation, whatever things we have done in the Jupyter notebook. So let's wait. After some times, you will see that your index would be created, and inside index, all the vector would be stored. So guys, as you can see, my index is created. Now if I open it up, inside that, now it will store the embeddings. One by one, all the embeddings it will set. So guys, as you can see, my execution is completed and it has stored all of my vector. Now that means my this store index is working fine. I'm successfully able to store my vector. Now let's create the endpoint. Okay, that means my main application. So user will start this application right now. So here I already told you we will be using Flask. Okay, so here I already told you we'll be using Flask here. And if I'm using Flask, I need a HTML and CSS code to create the one beautiful user interface. So I already created one HTML and CSS code for you guys. If you don't, it's completely fine. Again, I'm telling you, there are so many templates you will get over the internet. There is a website called Bootstrap. Previously, I also told you, I think Bootstrap. Okay, Bootstrap website. So from here, you will get different example. Even you can also see different template it is having. Even if you search like chatbot, HTML, CSS, free template. You will get different actually template. See, different template. You can also download the source code. You can see code is also visible. You can also download. Even you will get some website. See, different chat template. Okay, different chat template. You can use it. Okay, it's up to you. Now, what I will do, I'll quickly just show you the HTML CSS code I have prepared. For this, I think you know, if you are using Flask, you need to create one folder here called template. Okay, templates. So inside that, you have to create a file called index.html. Okay, now let me show you my HTML code I have prepared. Or it's a chatbot. What I can do, I can name it as chat.html. Okay, chat.html. Now this is the entire HTML code, guys, I have prepared. Okay, save it. Now I need to create another folder for the CSS called static. So these are the requirement folder for the Flask. If you're using Flask inside Python, you need to create these other folder. Inside static, I'll be creating a file called style.css. Okay, now let me also paste the CSS code I copied from the internet. Okay, so this is one basic template I created. Now whenever I will show you my application, you will see the user interface, whatever the user interface I created. Now let me create my endpoint app.py. Now inside app.py, I'll be integrating all of the functionality I have prepared so far. So first of all, let me all the required package actually one by one. So here I'm using Flask. So I have imported Flask. From the Flask, I have imported all the required functionality, you can see. Then imported download Hugging Face embedding model. Okay, because I need the embedding object to load my vector store. I think you know that I need to load this, note this actually Pinecone index. So where is the Pinecone index? So here is the Pinecone index. So I need to load this index, and to load this index, what I need the, let's say this one embedding object. I think remember at the last I showed you loading existing index. Okay, I think you need it. Okay, I think remember. Fine. So that is why I have to import it. Then I'm importing, you can see Pinecone store, OpenAI, Retrieval, QA. That means whatever, let's say I was loading here. These are the thing I'm loading everything. Fine. Then I also need to load my prompt. So prompt is available inside my prompt.py here. So I can import it. So simply I can import, just write prompt src dot prompt import start. That means I want to start everything inside that file. Okay, that's it. Then I also need something called operating system. So import OS. That's it. Now let me initialize my Flask. To initialize the Flask, you have to use this code. Go to the Flask documentation, you will get it. Now let's set all of my OpenAI and Pinecone environment. Okay. For this, I need to use the load in environment package. That's it. Then I will be downloading the embedding model. Then I will first of all initialize my embedding object. Then I will load my existing index from my Pinecone. So let me show you. See, the same code from the notebook I copied. See, So I'm loading the existing index, medical bot. Make sure name is correct. Medical bot. Yeah, it's correct. Then it will give me the retriever object. Then I'm loading the OpenAI model, then creating the prompt template. Then after that, I'm creating the chain. Okay. Now I have to create two routes exactly. First route would be my default route. That means user will get the interface of my application. Chat.html would be rendered. Got it? Now second route I'll be doing for the chat operation. That means user is giving any query to the chatbot. So that message actually I'll be accepting. And this message I will give to my LLM. Okay, that means you can see I'm doing the invoke operation. Okay, so same invoke operation I'm performing. Let me show you. So here is the invoke operation. Remember, okay, invoke. And whatever response I'm getting, I'm printing it as well as I'm showing in my that user interface. Okay, that's it. Now let me execute my application. So I'm running on my local host, port number 800, debug is equal to true. That means if you change anything, it will automatically update everything. So now let me show you my application. So let's open up my terminal. So I'll just execute Python app.py. Sorry, it should be Python. Spelling is not correct. Python. Okay, now it should be running. Now see, just give the allow permission. Now see, your application is running. Now let's open up our Google Chrome. Search for localhost port number 8080. See guys, this is the interface we have created. And this is one amazing interface, guys. You can see amazing chat template we have created. Because many people have requested me just try to create one front-end part of our application as well. Beautiful front-end part. And that's how we can create a beautiful front-end part. Now here you can ask any kinds of question. Let's say I will ask the same question. I'll ask what is acne. The acne is a common skin disease by characteristic by pimples on the face. Fine. Then I will ask another question. Let's say I got fever. What should I do? See, now this is the response. If you are experiencing high fever, it is important to seek the medical attention. Okay. So tell me some medicine. Now see, it is also suggesting some medicine, okay, related fever. Now you can ask any kinds of question from the, let's say, PDF itself, any kinds of disease you can ask. Let's say this is the disease I want to ask. I'll just copy. And here I'll just write what is this disease and all about. See, it has given me the response. Okay, now you can read this, PDF, and you can see that. You can ask the medicine, you can ask for the treatment, anything you can ask. So this is our chatbot, guys. This is our medical chatbot we have created. And see, it is also giving you the one beautiful user interface. Okay, it is also returning. Now, what we'll do, we'll just try to also deploy this application, guys. But before that, we'll be implementing some more end-to-end projects. Then after that, I'll keep one dedicated end-to-end, let's say, deployment session. There I'll show you how we can deploy this at the project on the cloud platform. Okay. So yes, guys, I hope you liked it. But before that, what I will do, guys, I will commit this at the code in my GitHub. So you can also commit from the VS Code. Let's commit from here. I'll write updated. Let's commit. And .env file would be automatically ignored by the git ignore, okay? Because inside git ignore, you have already mentioned it. .git ignore would be ignored. See, .env would be ignored, okay? So it won't be published inside my GitHub. Now if I open up my GitHub, now if I refresh, see, all the code has been updated. Now I can write the further code, let's say step as well in the readme file. Okay, so I have added all the step. Like after that, what you have to do, after that you can set your environment key, then run store index, then app.py, then you just need to open up your localhost. Okay, now let me commit the changes as well. So readme updated. And make sure, guys, you start this repository, all of you. Start this repository. You can also fork it so that you will have the reference. Okay. Now if I refresh, now see, readme is updated, and you can see all this step I have also added. That's how you can also prepare your readme file, so that if other people is referring your, let's say, GitHub, they will be also able to set up this code, okay, in their system as well. Fine. So yes, guys, this is the complete implementation. I hope you liked it. So that's how we can create any kinds of end-to-end generative AI bridge project. Fine. And no need to worry, I'll also show you the deployment. Even we will be also discussing about LLM ops. With the help of LLM ops also will be learning how we can access any kinds of open source large language model. Okay, as a hosted open source large language model, we can use it. So yes guys, this is all about from this video. If you liked it, so please try to subscribe to the channel, try to like it, and try to share it. Video will be implementing another end-to-end project called source code analysis. So here we'll be using LangChain vector database large language model. Even I will also show you how we can create a front-end application of the entire projects. So this is going to be completely end-to-end implementation, guys. So I think in our previous video, I already showed you one end-to-end implementation. We implemented one medical chatbot. So here we'll be following the same actually process to implement this project as well. Fine. And what is source code analysis? I'll tell you. I'll show you the entire architecture diagram of this project. Then I will start the implementation. So first of all, what I will show you guys, I will show you the GitHub repository creation. After creating the GitHub repository, we'll be making all the setups. Then we'll start the implementation. So let's open up our GitHub and let's create one GitHub repository for this. So guys, as you can see, I'm inside my GitHub. So here I'm going to create a new repository. And I'm going to name it as end-to-end source code analysis generative AI. Fine. So let's keep it as public repository. I'll select the README file and I will also take the git ignore wise Python. Then let's take the license. I'll take MIT license. Now let's create the repository. So after that, I have to clone it. So I'll copy the link address. I will open up my local folder and here I'm going to open up my git bash. Now let's write the command git clone and paste the link. That's it. See, it has cloned the repository. Okay, now I want to go inside this repository. I'll just write cd, that means change directory, to my end-to-end, okay, source code analysis. Now I'm inside this folder. Now inside this folder, let's open up our VS Code. So let me open up my VS Code. So here is my VS Code. So guys, I think you remember the first thing, we create a virtual environment, okay, for a new project. So let's create a virtual environment. For this, you need to follow some of the commands. So let me mention in the README file. So you can see these are the steps we have to follow. So first of all, if you're using my repository, first of all, clone it, then try to create an environment with the help of Python 3.10. So that environment name is LLM app. So for me, what I've done, guys, I already created the environment in my system. So I'll just activate the environment. But for you, if you don't have the environment, just try to create it. So let me show you my environment. I'll just write conda activate LLM app. See, it is already there for me. Okay. Now the next thing what I have to do, I have to set up the requirements of the projects. Okay. So for this, I'm going to create a file called requirement.txt. Inside that, I'm going to mention all the requirements actually I need. So you can see, guys, these are the requirement I need. I need OpenAI, TikTok, and ChromaDB. So vector DB wise, I'll be using ChromaDB. Previously, I used Pinecone. You can use any of the vector DB. It's up to you. Then LangChain, Flask. So the front end implementation wise, I'll be using Flask framework. Then Git Python. Why Git Python? I'll tell you. Whenever I'll show you the architecture diagram, this part would be clear. Then python.env just to manage my credential. Okay. And I'll be using OpenAI large language model. You can also use Gemini. You can also use open source large language model. But I told you, if you're using open source large language model, you should have good configuration machine. Okay, otherwise you won't be able to execute. And that part we'll be learning in the LLM ops, right? Now let me save everything and let me install all the requirements. So for this, you can execute this command. So let's copy the command and here I'm going to execute. See, for me, I already installed all the package. That's why it's telling requirement satisfied. But for you, it will take some time. Now, the next thing, what I do, guys, usually I create a template file. I think you remember, project template file. So templates.py. Okay. And previously I shared one template code with you. I think you remember. So I'll just copy paste the same code. So if you missed out my previous implementation, guys, please try to check the end-to-end medical chatbot implementation. So there I already explained this code. Okay, this code, how we have written and all, everything I explain in detail. Okay, see, I'm using the same code, same actually template code. Now what will happen, this code will automatically create the template for me. So I already created requirement file. I don't need it. I'll remove it as of now. Okay, now everything is fine. So now if I execute this template.py file, see, it will create my folder structure. So let's see. See, it has created the folder structure. And whatever log actually you have written, it is showing in the terminal, you can see. Okay. So my folder structure is created. Now what I will do, I think you remember, first of all, we perform the notebook experiment. That means we'll be implementing the entire projects in our Jupyter notebook. Then we'll try to convert as our modular coding. Okay. So for this, I'm going to open the resource folder. Inside that, I'm So inside research folder, I'm having one Jupyter notebook file called trials.ipynb. So here, first of all, let's select my kernel. So this is my environment. Okay. Now let's test whether it's working or not. So okay message here. Yeah, so everything is working fine. Now, first of all, let me show you the project architecture diagram, like what we are gonna perform here. So guys, as you can see, this is the entire project architecture. So here we'll be basically performing question answer over the code base to understand how it works. See what happens actually whenever, let's say, we implement any kinds of project. Okay, let's say previously, I think you remember, we implemented one project called end-to-end medical chatbot. And this is the code base we have created, right? This is the entire repository of our project. Now, let's say if anyone new to this field, if actually he's not able to understand this project like how I have written, let's say this person will open this project. Let's say he will open this helper.py. And now he's not able to understand what is this function actually, download Hugging Face embedding. Or let's say, what is this function, load PDF file and all. Okay, let's say anything actually he's not able to understand about the project we have implemented. He's not able to understand the code we have created, right? So what actually this application can do, so if you give this GitHub repository link to our software, my software, what it will do, it will try to first of all extract all the code from the repository, then it will create a knowledge base. Okay, and with the help of large language model, it will try to understand what you have written. Let's see, now if you're asking any kinds of question, let's say what is SRC? Inside SRC, let's say you are having helper.py. Now let's say you are asking, let's say what is text split function, what it does. So this model will try to read this code and it will able to give the like answer. This function does this thing, and that is how actually it is working. Okay, that means it will give you the entire explanation of the code you have created. Okay, so this is called actually source code analysis. Okay, now I think you got it. What is the project actually we are implementing? So project name is source code analysis. So basically here we'll be performing question answer operation over the code base. Okay, to understand how this code works. Okay, and this is the entire diagram you can see, guys. Let's say you are having a source code, that means a complete GitHub repository. Okay, that means the complete, let's say end-to-end implementation. So first of all, what you have to do, you have to first of all let's say extract all of the source code. Okay, then you will be creating actually chunk. Okay, different chunks. For this actually we'll be using something called context aware splitting. Okay, now I think you can see here we'll be using something called context aware splitting. So here is the context aware splitting, and how context aware splitting works. So let's say this is your entire source code, and I think you know inside Python programming we use functional programming, OP programming concept, right? So let's say you have created different function. I think I told you I had created different function. Let's say this is one function. Let's say this is one example, def4. Let's say this is the function. Inside that you are having some code. Now after doing this context aware splitting, what it will do, it will first of all extract all of the source code, then it will create different chunks. Let's say inside this function you are having let's say 200 line of code. Okay, 200 line of code. Now let's see if your chunk size, okay, chunk size, let's say you have given or let's say I can write 20,000 lines of code. Okay, now let's see your chunk size you have defined 500. Okay, 500. That means what it will happen, 500. Okay, 500, let's say what that means 500 these kinds of actually tokens would be considered as your one chunks. Now just try to consider how many chunks it will create. It will create different chunks. Obviously, let's say this is the first chunks, this is the second chunks, this is the third chunks. Let's say it has created 3 chunks. Okay, 3 chunks it has created. Now how your model will try to understand whether these chunks, the entire chunks, so it is related to this particular function. Let's say there would be so many functions, there would be let's say thousands of functions, but how your model will understand these 3 chunks I got, this chunks is related this function, def4 function. So what context aware splitting will do, it will automatically tag. So see, it is automatically tagging. So this is the chunks of def4 function. Okay, let's say you are having another function, let's say def test. Okay, this is the function. Inside that you have subcode. First of all, it will perform this splitting, that means chunking operation. You will get different chunk. Okay, then it will also perform the tagging operation. Let's say this is the tag of test function. That means your model will try to automatically understand now. Now your model will try to understand, okay, this chunks actually I'm getting, this is related to this particular function. Okay, so that's how actually it will understand the context. It will remember the context. Okay, this is called actually context aware splitting. And this context aware splitting we only perform whenever we are working with, let's say code. Okay, code data. Because previously we work with text data. Okay, text data is a different thing and code data is a different thing. That's why you have to follow this thing. Okay, now let me clear my screen. Now see what will happen. You have to create a Vector store, yes or no? You can see after actually getting all the text, okay, all the chunks, you'll be using embedding model. With the embedding model, you'll be creating vector store, and here we'll be using something called ChromaDB. Okay, ChromaDB will be using. Okay, then this would be your knowledge base. Okay, and you'll be connecting your large language model. After that, whatever question actually user will ask, okay, let's say this is the user. Whatever question user will ask, it will take this actually relevant answer as well as the question. It will try to understand. Based on that, actually, it will give you the actual response. Okay, so this is the entire application we'll be creating. And again, you can see here we are implementing something called one RAG application, retrieval augmented generation. Okay, because here we are feeding our custom data. Custom data wise, we are using code data. Okay, our let's say source code we are using here. So I hope now it is clear. Now let's start the implementation, guys. So first of all, let's implement everything in our Jupyter notebook. Then we'll try to convert everything as our modular coding. Now let me clear my screen. Okay, so first of all, let's import all of the library I need. So here you can see I have imported all of the library actually I need in this implementation. Now the first library I'm importing called from Git import repo. So I think you remember we installed one package called Git Python. Okay, so what is Git Python? Git Python is nothing but this is the package like Git GitHub. Okay, this is the GitHub actually package inside Python. That means with the help of this package, you can clone any kinds of repository from the GitHub. Let's say the way actually cloned. I think you remember we open up our terminal, we just written one command git clone, then we pasted that link, right? We pasted our repository link. I think you remember. Okay, and it was able to clone this repository in my system. So now if I want to do with the help of Python programming, how we can do it? For this, we'll be using this package actually, Git Python. Okay, so with the help of that, we'll be easily cloning any kinds of repository from our GitHub, because I told you now user will upload one URL. Okay, that means GitHub URL, project URL, and from the URL actually it will automatically, let's say, clone the repository. Then it will extract the information, that means your code base. Then it will perform the chunking operation, embedding model, store the embedding in the knowledge base. Then it will connect the LLM. Okay, that's how we'll be performing the entire operation. Got it? And here I'm also importing another package called language, because here we'll be using programming language. So I'm going to use Python programming. So with the help of language, actually I'll try to use Python programming language here. Then generic loader, language parser, recursive character text splitter. Okay, so these are the actually additional package I'm also importing, and I'll tell you whenever I will be using them, I'll tell you each and everything. Okay, why I'm using it and what is the use of it. Now you can see I'm importing OpenAI embedding, because I'm going to use OpenAI embedding model. Then ChromaDB vector database, I already told you. Then we'll be creating our chain. Okay, the complete chain, and here we'll be using actually memory, conversation summary memory, because I think you remember in our LangChain series actually we learned how to create the memory. Okay, like it will remember your previous context. So with the help of this conversation summary memory, we can also create a memory buffer. Okay, so this thing actually we have imported so far. Now let me execute. Now see, it should work fine because we have installed everything. Now the next thing what I will do, guys, I'll just create a folder here. So mkdir. So this is the command to create a folder. I'll name it as test repo. Okay, test repo. Now see, if I show you my project working directory right now, so pwd project working directory, I'm inside resource folder. So inside resource folder, it will create a folder called, okay, mkdir is not recognized. Okay, see, it should be mk. Okay, not mac. Now it should work. See, now in the test folder, it has created one folder called test repo. Inside test repo, I'm going to clone the repository. And to clone the repository, guys, you can use this code snippet. So here I'm using this one actually. I think remember a repo. So the repo actually I have imported from Git. So inside that, you have one function called clone from. Now you have to mention the URL, like which repository you want to clone. Let's say I want to clone this medical chatbot repository. I've given the entire link. So this is the link I have given. Just copy the link and try to mention. Here you can give any kinds of URL, any kinds of GitHub URL you can mention here. That repository would be cloned. Then after that, you have to define the path. In which path you want to clone? I want to clone inside this particular path. Okay, this folder. Now see, if I execute, it will automatically clone this repository inside the test repo folder. Let me show you. Execution done. Now inside resource test repo, see, it has cloned all the source code. See, all the source code you can see it has already cloned. Okay, amazing. Now the next thing will be loading all the codes. Okay, all the, let's say, codes, all the data from this repository itself. Okay, all the Python file will be loading. That means we'll be extracting all the source code. For this, I'm going to use this code snippet. So here is the code snippet, guys. So here I'm using generic loader from file system. So I think remember we imported this generic loader from LangChain. Okay, generic. Now here I'm giving the repo path. That means where my repo is present. Then I'm giving the globe. That means it will open. That means it will extract all the Python file. Okay, .py file. Then parser. You have to mention the language. So here it is the Python language. Okay, that's why you have to give the Python language. And parser threshold, you just keep it this particular number 500. Okay, this is the default number, you can keep it. Now it will give me the loader object. Okay, now from the loader object, I will load the documents. Now see, it will give me the entire documents right now. If I show you, see, all the content is as extracted. Okay, now if you want to see them, now how many documents you got, you can check the length of documents. You'll see that 7 documents actually I got. Now if you want to see any kinds of specific, let's say, documents, you can print it. Now you can see this is the entire source code. You can see it as extracted, okay, from my repository itself. Now the next thing, guys, will be performing this context aware splitting. Okay, context aware splitting, I already told you, we'll be creating the chunks, and this particular chunks will tag with the function name. For this, we'll be using this this particular code snippet. Let me show you. This is the code snippet, guys. Recursive character test splitter you can use, and inside that you only need to mention one parameter called language is equal to language.python. So it will automatically perform the context aware splitting. That means it will tag the chunks with respect to the function. Got it? And chunk size and chunks overlap I have given. Now let me execute. Now I'll apply on top of my entire documents. Okay, document splitter, split documents. I'm passing my documents. Now it will give you the entire chunks. So let me show you. So this is the chunks I got. If you want to see the length, you can also see the length. Okay, see, this is the length of my chunks. Got it? Then next thing what I have to do, guys, I have to actually use the embedding model. Okay, to convert all my source code to the embedding representation, and I will be storing to my knowledge base, that means ChromaDB. For this, I will be using OpenAI embedding model, I think, remember. So let's set our OpenAI environment API key here. So this is my OpenAI API key. So I already created and I already set here. Now let me save. I'll go back to my notebook. Now, first of all, let's load this API key with the help of .env package. So here you can see I'm loading it. Then I will set this API key as an environment variable. Then I'm going to initialize my embedding model. Okay, OpenAI embedding model. That's it. Now let's initialize my ChromaDB. So I think you remember we imported already Chroma from LangChain here. So Chroma we already imported. You can see vector store Chroma we imported. Now inside ChromaDB, we are passing our text. That means the chunks actually I created, and the embedding model as well as the persist directory. That means it will create a directory. That means database. Okay, so instead of data, you can give database. Okay, DB. Okay, DB. So it will create a database, like local database. Inside that, it will save all of your embeddings. And ChromaDB session I have already taken in the YouTube channel. You can check it out how ChromaDB works. Okay, now let me create the vector store. Now see, DB has created. Okay, inside resource, and it is converting all the code to the embedding representation. And it is saving inside DB. Now see, it has created the local database. Okay, see. Okay, now what I'll do, I'll just make it as, now to activate this vector DB, you have to execute this line, vector db.persist. Okay, now I'll be initializing my large language model. So here you can use any kinds of large language model. You can also use GPT-4. I'll be using the default model like GPT 3.5 Turbo. So let's initialize my LLM. Then I'll be creating the memory. That means that history memory, conversation summary memory. You can see I'm importing this library. And inside that, I'm passing my large language model. Then memory key is equal to chat history. That means it will remember my previous context. Okay. Then return message is equal to true. So this is going to be my memory object right now. Then I'll be creating my final chain. So for this, you'll be using a conversation retrieval chain. Okay. Now inside that, give the LLM retriever vector database. Okay. And as retriever, so search type, I'm giving MMR. Keyword, it will give me 8 relevant answer. And here I've given the memory. Okay. Now this is going to be my key object right now. Now let's ask one question. So I'll prepare one question here. Question is equal to, let's say, I'll go to the test repo. Inside that, I'm having src folder. Inside helper, I'm having one function. Let's say download Hugging Face embedding. I'll copy this function name, and here I will ask what is download Hugging Face embedding function. Okay, let's see whether my model is able to explain or not. So this is my question. So this question I'm going to pass inside my keyword, that means my chain. Okay, and it will give me results, and I'm going to only extract the answer, okay, from the result itself. Now let's see. So guys, you can see I got the answer. The download Hugging Face embedding function downloads the embedding from the Hugging Face model. So this is the model actually. Okay, now see, if I open it up, see, it is correctly identified this model actually we are trying to download, and which returns embedding of 304 dimensions. These embeddings are used for the processing and analyze text data into context of the application. That means correct information. Okay, amazingly, it has explained this function. Now you can give any other question. So what I will do, I'll copy this question and let's ask about this function right now. Let's say I'll ask about load PDF file. Okay, this function right now. Let's see what it will give me. So I'll copy the same code. And here I can mention, I think. Now let's see. So ignore this line. Okay, this line is not required. So this is your actual response. The load PDF function loads the PDF file from a specified directory using directory loader class, which is a filter of PDF files. And then it extracts the documents and return the items. Amazing, guys. So that's how you can perform the QA operation with your code base right now. If you don't understand any kinds of code, if you don't understand any kinds of function, just try to, give it here and try to ask it. So it will give you the entire explanation of your code base. Okay, this is called actually source code analysis. And this is one of the amazing project, guys. Amazing project. Got it? Now, this is the actually notebook experiment. Now let's try to convert this project out as our end-to-end implementation. Okay, so I'll just do the copy paste operation from my notebook only, because I think I showed you in my previous implementation, I did the same thing. So now what I will do, guys, I'll open up my SRC folder inside helper. So whatever, let's say, code I have written, okay, then let's say individually, I was loading the, I was cloning the GitHub, I was extracting the data, I was performing the embedding model operation. Okay, so everything I'll just write as a function inside helper.py. Okay, so now let's do it. This is how actually I implemented, guys. So I'm importing all of the necessary library. Then first of all, I created one function called repo ingestion. It will take the repo URL and it will do the ingestion operation. That means clone operation. The same thing we are doing in our notebook only. Got it? Then second function I have written called load repo. The same code, guys. That loader, generic loader I'm using here. See, it will take the repo path and it will load the, let's say, code, and it will give you the documents after extracting. Then the third function I've written called text splitter. That means it will perform the context aware splitting. Okay, the same thing. Then it will give you the embedding model. Okay, it will first of all get the embedding model from the OpenAI. It will return you. So instead of actually writing the scripting, I've just written as a function. That's it. Now the next thing what I will do, I'll add everything inside my endpoint, which is nothing but my app.py, because app.py user will execute and they will get one user interface, and from there actually they will upload, let's say they will give the URL, they will do the QA operation. Okay, so for this actually I already told you we'll be using Flask, and for the Flask actually you need one template and a static file, I think you remember. So let me show you. I already prepared one HTML and CSS code for you. So guys, as you can see, this is the template file, and inside that I'm having my index.html, and this is the HTML code. And again, I refer the internet bootstrap website to implement this actually HTML and CSS code. If you're not aware about, it's completely fine. You can use my template as it is. Okay. Now inside the static folder, I'm having the CSS. That means CSS code. Okay. That means style of our web interface and all. And to execute this style.css, I am using some JavaScript actually code. You can see this is the JavaScript code. Again, I got it from the bootstrap website. Now see how your application will look like. I'll tell you. Before that, let me write this app.py code. So inside app.py, I'm going to import all of the library I need. So you can see I'm imported all of the library like ChromaDB, load embeddings, okay, from the SRC helper, because I need the embedding model, right? Then repo ingestion, I'm also importing from the SRC. Then my chat OpenAI, okay, function, then conversation summary, okay, conversation retrieval chain. So everything you can see in the notebook, I'm importing all of them here. Now, first of all, what I have to do, I have to initialize my Flask, and I will set the OpenAI environment key as my environment variable here. That's it. Okay, see. Now, first of all, I will load my embeddings, okay, from my vector database. You can see I'm loading the embedding from my vector database. So for this, before that, what I have to do, I have to first of all generate the vector embedding. Let's say if user has given the URL, so it will generate the embedding, right? It will create the embeddings and it will say inside my vector database, yes or no. So for this, I'm going to create another file called store_index.py. So previously in the medical chatbot implementation, I written the same file, I think, remember. Inside that, I was doing the actually embedding storing operation. See, so you can see repo ingestion, load URL. So I'm importing everything. I'm setting my OpenAPI key. Then load repo. That means see, user will give the URL. So this URL actually repo ingestion will load, and it will load the, let's say, documents. It will perform the text splitter embedding. Then this embedding will store inside my like ChromaDB. ChromaDB will create a like local database. Inside that it will save everything. Okay, I think you remember. Now here I've commented this 2 line because I will be doing this thing with the help of user interface. That means UI. Okay, not manually actually. So that means from the app.py user will give the URL. Okay, from the user interface, web application user will give the URL. This URL I will receive here. Okay, I'll receive here, then I will execute this line of code. Okay, so that's why I've commented this line. But if you want to test what you can do, you can uncomment it and you can execute this line. You will see that it will work fine. Okay, so as of now I've just commented out. Now let me save it. Now I'll go back to my app.py. Now let's create the LLM chain. So this is the chain. The same code I've copy pasted from my notebook, guys. I'm creating the LLM, creating the memory. After that I'm creating the QA chain. That's it. Then I'll be creating 2 route. Then I'm going to create a route actually from my Flask. So this is the default route. First of all, it will render the index.html whenever user will open the application. Okay. Then the second route I'll be creating for the repo ingestion. So whenever user will pass the URL of the GitHub and they will submit. So what will happen? It will execute this store index.py. You can see I'm executing this command, python store index.py. And if you want to execute any Python file, that means if you want to execute any command, you have to use system, voice.system. You can see I've imported operating system. So voice.system, and inside that just give the command, it will execute this file. That means what will happen? Whatever URL user will give. Okay. So first of all, it will perform the repo ingestion. I think you remember we created the repo ingestion function. Repo would be ingested in the repo folder. And if I go it back, now see. Now it will execute this store index.py file. That means this file. Now this code will be executed. That means it will load the repo, extract the documents, create the chunks, load the embedding model, then store all the embeddings to the knowledge base. That means inside my ChromaDB vector database. Okay. Now I think you got it. Now see, this is my second route. Now I'll be creating another last route. This is for the chat operation. That means after ingesting the data, creating the knowledge base, it will perform the chat operation. User will give the message. Okay. And if message is equal to clear, it will remove your let's say entire repository. That let's say you want to clone another repository, so your previous repository should be deleted. Okay, otherwise what will happen? It will take all I mean space. Okay, in my system. That's why I'm removing it. I'm doing the you can say rm.rf operation. That means it will remove it. So this is a Linux command. That's why I'm executing inside voice.system. Okay, then after that, whatever input user is giving, I'm getting the results. I'm rendering the answer. Okay, that's it. Now let's open up my application and let me show you. Now I think this part would be clear. So I'll open up my terminal. Now let's execute my app.py. So app.py will open. It's running now. Let's go back. Now just search for localhost port number 8080. Now see, this is the interface of your application. Okay. Now here you have to give the URL. So let's say I will give this URL. I'll just give it here. Now see, I'll just send it. Now see, in the backend, what will happen? It will ingest. That means it will clone this repository first of all. After that, it will create the embeddings and it will save this embedding in the vector database. Now see, internally everything is executing. If you go here, now see, repo, it is cloning as well as DB would be also created. Now let's wait and let's try to see. So guys, as you can see, my execution is done. So if execution is done, you will see this message actually, response. Okay, response. So now if I open it up, now see, my repo has ingested and also my DB object is created. That means my embeddings has already stored here. Now I can perform the QA operation. For this, I'll be using this template right now. And this is the same actually chatbot template I'm using from my medical chatbot. Okay. Now here you can give any kinds of question. Let's say I'll give what is. I'll ask the same question again. So I'll open the repo src helper. Let's say we'll ask this one, download Hugging Face. Like what is this function and all about? Function. Let's see. See, this is the answer I got. The download Hugging Face embedding function responsible for downloading the embedding model from the Hugging Face called sentence this model and specify return the 384 dimensional vector. Great. Now I'll ask another question. What is this function? Let's say text split. See, text split function. See, text split function purpose is to split the extracted data into smaller text chunks. These text chunks are useful for the processing and analyzing the text in a smaller, more manageable section. Great. That means it is giving you the correct response. Now you can ask any kinds of question regarding your source code. Okay, so this is the entire implementation, guys, of our project. Yeah, so I think you liked it, guys. And in the next video, we'll see the deployment, like how we can deploy these kinds of projects, okay, to the like cloud platform. So for this section, we'll be using AWS. So in AWS, I'll show you the deployment part. So before ending the session, first of all, let me commit the changes in my GitHub. So I don't want to push the repo. Let's say this repo I don't want to push. So what I can do, see, let me show you another thing. Let's say if I give clear message here, it will remove the repo folder automatically. See, repo folder would be deleted because you have written the code here. I think, remember, inside helper, not helper, I think inside app.py. See here, if you give the clear, it will remove the repo folder. Okay, now if I click here, now see, then I also don't want to push this db objects. What I can do in the git ignore, I can mention this db. Let's say db would be ignored. Inside everything, just try to ignore. Now let's try to see. db is also okay. Another actually repo I'm having inside resource. So let me also mention resource also. Inside resource, I'm having test repo. So everything I want to ignore, as well as I want to ignore the db as well. Now I think, okay, research spelling is not correct, so it should be like that. Okay, research. Now let me save. Now see, it is ignoring everything. Okay, now let me push the changes. So I'll just write updated, commit, and seeing the changes. Now if I get back and refresh here, see, all the source code has been updated. Now let me write the further step you can perform. So here I have added the next step, like you have to create the environment file. Inside that, just set your OpenAI API key and just run app.py, and you can execute your project. Okay, that's it. Now let me also update this readme file. Readme updated. Now let's refresh here. Now see, everything is mentioned. Okay, all of the command I have shared with you.
So before starting with our Chainlit discussion, first of all, I just wanted to tell you something like why we should use this Chainlit. And as a data scientist, actually, what are the difficulties actually we face whenever we try to develop any kinds of application, right? So I think you have used something called Streamlit to create your this kinds of web application. Even I have already showed you how we can create end-to-end like these kinds of generative AI projects with the help of Streamlit and all. See, whenever we are using Streamlit, it's a initial interface, right? Initial like demo of your application. But nowadays actually this LLM comes and people are creating lots of application on top of these kinds of LLMs. And also, like, there are lots of application, there are lots of product in the market right now, like ChatGPT is there, Google Bard is there, right? Then Microsoft Bing Chat is also there. So if you have seen these kinds of product, these kinds of application, so you will see like this application has like very beautiful user interface, right? So whenever, let's say, I'm creating any kinds of conversational agents, okay, let's say I'm creating any kind of chatbot, so we should have one like very beautiful user interface. Otherwise user might not get interest, okay, with your application. So that is the main thing actually. And Chainlit provides actually this kinds of beautiful user interface whenever you are trying to create any kinds of conversational agents and all. So we can use this Chainlit to build this kinds of LLM app super fast. Okay, I will tell you like why it is super fast, because you will see using very short line of code will be creating these kinds of application very easily, right? But if you're using Streamlit, I think you saw we need to write some more code there. Okay, but if you're using Chainlit, so like more code doesn't required here. So only using some line of code actually will be able to complete our entire projects. Okay, so this is a like very amazing package I was exploring, and I thought let's also show you this one. So that actually whenever you are learning these kinds of large language model, generative AI, so at the end you need to build some application, right? So you can use this kinds of Chainlit package with your application. And there is another reason actually you should use this Chainlit, you should explore this Chainlit. Let's say you are building some projects for your client, so you need to submit that projects to your client. So you need to submit some good you can say output from your side, otherwise your client might not get interest. So at that time, if you're using this kinds of Chainlit interface, okay, Chainlit package to create your apps and all, so it would be very much realistic and it would be very much amazing to your client whenever they will look into your application. So that is why actually whenever you are trying to build something, you have implemented any kinds of POC and all, so at that time just try to use this kinds of Chainlit package to create your apps, so that actually you can submit some good application to your client, okay, and they will be very much happy with you, right, with your work. So guys, this is the video agenda. So first of all, I will take you through the Chainlit documentation. Then I will show you like how we can use this Chainlit, and we'll be building one basic chatbot here. So I'm going to implement one food delivery chatbot. So basically it will asks for the order, okay, it will suggest you the food, then it will ask for the location, and it will take your order and all. So these kinds of chatbot actually will be implementing. I think you have seen like Zomato, right? So we'll be building some something like Zomato. You can build anything, but this is the project actually I prepared for you, so that actually you can learn something, right? So I just wanted to make you this thing as realistic, so that whenever you are building your own projects, okay, you will get interest. So yes guys, this is all about. Now let's start with our Chainlit discussion. So guys, as you can see, this is the Chainlit documentation, and Chainlit is nothing but Chainlit is an open source Python package that makes incredibly fast to build ChatGPT like application with your own business logic and data. As you can see, if I open ChatGPT, so here you will see it has one beautiful user interface, okay, that's why user are more interested to use this kinds of ChatGPT kinds of application. Now let's see, if you give any kinds of message, so it will take your message, even it will reply like that, okay. So we'll be building something like that, so it would be like ChatGPT like interface, right? Then if you see here, it has also official tutorial, so you can also visit the tutorial they have given. So from there actually you can also learn, but I will make this video very simple, so that actually you can understand each and everything. You don't need to go through even the documentation. I will discuss everything, whatever things actually you need to explore, okay. And apart from that, anything is left and anything you want to explore from your side, you can visit the documentation and learn, okay. Yes guys, this is the documentation, as you can see, and it has also integration with this kinds of LangChain, then AutoGen, Llama Index, okay. You can either use OpenAI, either use LangChain, either use Llama Index, anything you can use, okay. All the things has been integrated with that. So in this video actually I'm going to use OpenAI API. That means I'm going to use GPT 3.5 turbo model to create this application, because I just want to show you quickly. That's why I will be using this OpenAI model, because there actually I will get one API key and everything would be done for me, right? But you can also use open source large language model. I think I already taken some of the session, like how we can use Google PaLM 2, Llama, then we have Llama 2, then we have Falcon, we have Mistral 7B, anything you can use here. You can also integrate LangChain with that. I have already showed you like lots of things with the help of LangChain and all. So you can explore this thing, right? So yes guys, this is the documentation. Now here they have already given some starter code, like how we can start with this Chainlit and all. So I'll show you like how we can launch this Chainlit app and all, okay. But before that, what I need to do, I'll be creating one GitHub repository. So here's my GitHub. So let me create one GitHub repository. I'll name it as LLM app with Chainlit. You can give any kinds of name. So let's keep it as public. I'll add readme file. Then git ignore wise, I'll be using Python, and license, you can take any kinds of license. So let's take MIT license. Then I will be creating my repository. Now let's clone this repository in my local machine. So I'll copy this link address and I will open my local machine, and here I'll open my terminal. And just write git clone and paste this link and clone it. Okay, now I'll redirect to this folder, LLM apps with Chainlit. Now I am inside this folder. Now here I will launch my VS Code. So you can use any kinds of code editor, it's completely fine. So I already opened my VS Code. Now here I'll be creating some of the like folders and file. Then we'll be doing the environment setup, because I need to install some of the libraries, like let's say Chainlit I need to install, then I need to also install OpenAI and all. Okay, so let's do it and see like how we can use this kind of Chainlit. So here I'm going to create one folder. called src. And then inside src, I'm going to create one file called __init ___ dot py. I think you already know why this constructor is needed, because I'm going to consider this src as my local package, because here I'm going to writing some of the Python file, and from that file I'll be importing some of the function and all. Okay, that's why I need to create it. I think I showed you in my end-to-end process, okay, what is the use of this. Then inside that, actually I'm going to create two more file. One file I will keep my LLM model, and another file I will keep my system related configuration, or you can also talk about this prompt. Okay, you can also tell it as prompt. So prompt dot py. Yeah. Now outside I will create another file called app.py. app.py. Then I also need something called requirement.txt. So requirements.txt. Then I also need something called setup.py because of this local package installation. Yeah, so this thing is required. Now let me just write down all the requirements actually I'm going to use. So the first requirement, actually I need something called chainlit. So chainlit. So this is the package you need to install. Then I need something called OpenAI. Then I need something called python.env. I think you know why we need this .env, because I'll be keeping my like OpenAI credential inside this .env file, and using this python.env I will read that. Yeah, then I also need something called -e space dot because of this setup.py. Now let me create that file also, .env. So here I'm going to paste my OpenAI API key. So I already created this API key. So you can also create your own API key. Okay, don't use my one. I will just remove it after this recording. Then I need to install, these are the requirements. So for this I need to create one virtual environment. So I'll open my terminal, and here I'll just write conda create -n. Let's name it as chain, or I can give yeah, chainlit demo. This is the environment name, and Python version wise I'll be using Python 3.9 and -y. Now let's activate my environment. Now I'll be installing the requirements. So just write pip install -r requirement.txt. Okay, it's giving error because we haven't added like setup.py code here. That is why it's throwing error. So I think you remember. So this code actually we usually add inside our setup.py. So this code is responsible to find this constructor file, and it will set up that folder as my local package. Okay, and here you can check the project name, version, author name, email address, and anything. Right, now let me install them. So now I'll again execute my requirement.txt. So it may take some time. Let's wait. I'll come back when it is done. So guys, as you can see, my installation is done now. Yeah, so everything is done. Now let me select the environment I created here. So it was chainlit demo. Yeah, that's it. Now first of all, let's test it whether everything is fine or not. So I'll close these are the file first of all. Yeah, so I'll visit this documentation again, this chainlit documentation, and if you click on in pure Python, so they have given one like code here. So let me just copy. So this code, actually this is the echo bot. Like if you send anything, so it will respond the same message, okay, as echo. So it's just for the testing purpose, like whether we are able to launch our chainlit app or not, and it is working fine or not. Okay, so first of all let me check it, everything is fine or not. Then I'll add my logic. I'll add my chatbot logic here. And here if you see, this code will remain same, and here you just need to write your logic. Okay, here we'll be writing our custom logic, and this code will remain same. Okay, and this is the ecobot currently. Now here, what I need to do, I'll open my terminal, and if you visit the documentation, so they're telling, first of all, you need to write one command called chainlit init. Okay, first of all, you need to initialize the chainlit here. So it will create one folder here called .chainlit, and inside that it will contain all the configuration. See, it has created this chainlit. Inside that it has created another toml file. This is the configuration file, and it has all the configuration. Okay, so here is the configuration. So you can change this GitHub URL and all. Okay, you can also change the project name here. So here is the project name, you can also change it. So this kinds of configuration you can change. So I'll just keep it as default, no issue with that. Then I'll again open my terminal. Again I will run one command called chainlit run app.py. Okay, now if I execute this command, so you will see it will launch one server for me, and this, it is running on localhost port number 8000. So I'll give allow access, and this is the default user interface. Okay, so why this message is coming here, welcome to chainlit and all. So if you see here, it has created one md file here. Automatically it has created one .md file, like markdown file, and these are the content actually it has automatically generated. Okay, now let's see if I change anything here. So let's say I will change welcome to my bot. Okay, if I change anything here, now if I go to my app and refresh, see, it has changed. That means if you want to, let's say, print any kinds of messages, okay, whenever user will launch your application, okay, so you can customize here. So I already created this md file. I already made some customization there, because I told you I'm going to implement something called this one Zomato bot. Okay, so for this actually I created some of the content related Zomato, and again I generated these are the content with the help of ChatGPT. Okay, so let me show you like what are things I have done. So here I'll just copy paste. See, this is the content I prepared. Hello, welcome to Zomato bot, and here I'm just showing some of the item like we have pizzas, then pasta, noodles, then Asian cuisines. Okay, so these are the thing actually I have generated with the help of ChatGPT. So here you can give anything, any message, whatever you feel good, you can give it here, and whatever application you are building with respect to that, just add the content here. Now if I go back to my application and refresh it, see guys, now it has changed to this content. Okay, now let's see if I give any kinds of message here, hi, so it will give me the same response like hi. Okay, now if I open my ChatGPT, and if you just compare with the ChatGPT, okay, now see, it's looking like ChatGPT only, right? So that's why they're telling Chainlit is nothing but it's a like a open source Python package, and with the help of that you can create ChatGPT like interface. Okay, ChatGPT like application. So I love this Chainlit a lot, because see, only using this line of code, okay, only using this line of code, like this only using just one function, we are able to launch this kinds of user interface. Now let's see if you're building any kinds of product for your client, so if you submit like that, so they will be pretty much impressed by your work. Okay, so that is why actually we should always use some good user interface whenever we are delivering our application, right? Now here you can give any message like I am Bappy, so it will give you the same response. Okay, because we have created the ecobot. How it is working, so let me show you. So they have created one function, and this is the decorator they are using, this chainlit decorator. So this decorator is handling everything, and again they're using async and await, because async and await is helping us to read this message, okay, real time. So it is always sensing our input, and whenever we are giving something, it is receiving, and it is also sending the message to the front end, right? So this is the like code, simple code. Now here we'll be writing our custom logic. So basically we'll be building one Zomato bot with the help of this large language model. I'll be using like OpenAI GPT 3.5 Turbo, and here we'll be chatting with our bot, okay, with the help of this Chainlit. And here if you see, your app name is chatbot currently, so you can also change this name. So I told you there is a configuration it has generated. Now if you go below, so here is the option to change the name. So by default it is chatbot, so you can also give something called chatbot for Zomato. Okay, now if I refresh and again refresh here, I need to, I think, stop the execution. So I'll open my code. Now guys, see, this name has been changed, chatbot for Zomato. Okay, now I can close the previous one, and again it's the EcoBot. Now guys, let's add our custom logic. So for this, first of all, I will prepare my LLM, that means large language model. So this is the file. So here, first of all, I'm going to import OpenAI. So I think you know OpenAI has been updated. Now it is latest version. So they have upgraded lots of things. And if you visit that documentation currently, so if I go to this OpenAI, openai.com, and if I log in, so this is the documentation. Now let's go to any kinds of task and let's see how we need to import. See, this is the input and we need to initialize this client object. Okay, but initially we just need to install import OpenAI. Okay, that's how we can do it. But now actually you need to import like that from OpenAI, import OpenAI. Okay, so this is the updated version of OpenAI, and if you see here, we need to upgrade it also. Okay, if you are using previous one, so you need to upgrade also. Okay, so this is the requirement you always need to follow. You always need to upgrade with the documentation, otherwise you might get some issue. Okay, so let's import OpenAI. So from OpenAI, import OpenAI. Okay, so I need to make one client object here, client OpenAI. Then here I will be initializing one function. I'll create one function, so I'll name this function as ask order. Okay, ask order. So this function will this is going to be like main function. So basically this function will give me the response whatever question actually user will ask. So it will take the message. First of all, it will take the message, then it will also take the model. So model wise I'll be using something called GPT 3.5 turbo, 3.5 turbo. So this is the model I'm going to use. You can use any kinds of model. You can use GPT-4, anything you can use here. I'll be using this model because this model charge would be a little bit less for me, so that's why. Then I will also take this temperature value. What is temperature? I think you know in LLM. Temperature is like how much randomness you want from your model. Okay, if you're giving it to 0, so that means it won't be giving any randomness. It won't be like more creative. It will give you auto, always stick output. But if you're setting it to close to 1, that means you're telling your model to take risk, and it will also generate some random output. Okay, so that's why this temperature parameter is important also. Now this is my function. Now here they have already given like how to initialize this one. If you see here, so we need to use something called client.chat completion.create. So let me copy this line. I'll copy this line. Then I will open my code, and here I will add it. Now inside that, I think you saw, first of all, it will take the model. Model is equal to model. Then it will also take something called message. Okay, message. So what is message here? So let me show you. See, message is nothing but it's kinds of prompt actually you are giving. Basically you are giving some like zero shot or few shot prompt here. Like you are telling this is the role. Okay, role means system means like you are the role. Okay, like you as a chatbot, this is your role system, and this is the content. So you are a helpful assistant. Okay, basically it is I'm telling to my bot you are a helpful assistant, and whenever user is giving some content, okay, let's say this is the content user has given, so you also need to reply as an assistant. Okay, as you can see, this should be your answer. So that means we are giving some prompt here. Okay, we are just giving some zero shot or few shot prompt here to my LLM, so that my LLM can understand what kinds of job actually I want to perform. Okay, so I think you already learned this prompt engineering and all. Okay, so this is very much important here. So let's also define this one. So I already prepared one prompt here, so let me show you. So you can also create your custom prompt. There is no issue with that. So in this prompt.py, I'll paste it out. So this is going to be like very creative. The more good prompt you actually will give to your LLM, the more good results actually you will get. Okay, so this is the prompt actually I've developed. So system instruction, as you can see, you are a Zomato bot, an automated service to collect other orders from online restaurant. Okay. If you see here, so many like content I have written here. Like, so here I'm just trying to making my bot understand like what it is going to do exactly. And these are the actually item I also like pasted here. So if anyone is asking like for the menu, so it should return something, right? So these are the actually prompt I have developed from my side. Okay. So this prompt actually I'm going to use. Now I think you remember you need to create one format, as you can see, role as system assistant. So that's kinds of format actually you need. So for this actually I already prepared. So this is going to be the format, as you can see, message, role, system, content, and system instruction I need to import from my prompt. So here I'll just write from src dot I have llms, oh no, sorry, src dot prompt. Then I need to import something called system instruction. Okay, so here is my system instruction. I'm importing this one. Now here I'm just telling role, system, and content. Okay, so here I'm giving the prompt to my LLM, as you can see. Now this message actually I will give it here. Okay, yes. Now I also need to set the temperature. So temperature is equal to temperature. Okay, now this will also return something, as you can see if you go below. So this is the response format. It will give you this kinds of format as a response. It's a JSON format response. So from here actually I will need to collect this content. Okay, if you see here I need to collect this content. Okay, content is the response, okay, actual response, and these are some parameter it will also give you. So if you want to like extract the content, so you can copy this, either you can also copy this one, you can also copy this one. Okay, this one also you can copy. So let me copy this one and I'll open my bot again, and here I'll just write return response.choice message.content. I only need the content. Okay, so this is my function I have developed. So it should be messages instead of messages. Yeah, now it's fine. So now I will write my final logic. So I'll open my app.py. So here first of all I need to import my this function ask order. So let me import. So from src.llm import ask order. Then I also need to import something called messages. Okay, because here if you see we have also created this messages. I also need this one here. Let me save it. Then if I show you now here, if you see here, whenever I was discussing this thing, so you need to prepare this message. Okay, we have created for the system. Okay, system, that means we have given the prompt. Now I also need to create for the user. Okay, like whatever input user will give. Okay, so for this, in this list actually, if I show you, we have a message. Okay, this is the list actually, and inside that we have a dictionary. So I need to add some more, like you can say I mean messages, as you can see, one by one. So this is for the system. Then I also need to add for the user as well. Okay, so I need to just append it. So for this what I need to do, so I'll open my app.py, and here you can append like that. So I'll just write message.append, and here I'm just initializing my user right now, role, this is user, and this is the content. What is the content user will give? The message. Okay, the message actually will send. Okay, the message actually will send from here. So this is going to be the content. So it will store here. Okay, it will store it here. That means in this list, because we are doing the append operation, right? So once it is done, I also need to give this message. Okay, I also need to give this message to my bot. So I'll just write ask order. Inside that it will take the messages. Okay, then it will also give me something called response. It will give it will give me something called response. Okay, now if you see here, I also need to provide the response here. If I show you, I also need to give the assistant response as well. Okay, as you can see, assistant response as well. So again I will append. So whenever I will receive the response, okay, I will extract the content. So as an assistant, actually, it will give me some response. So this response actually I am appending, because if I show you here, this response should be my content. Okay, as you can see, it is returning the content, and that content actually I am storing. Now once it is done, now I also need to send the response to my this Chainlit user interface, right? So to do it, actually, if you see by default, it is sending the like echo command only. The message user is giving the same message actually it is sending. So instead of that, actually, I just need to send my response. Okay, this is the response. Actually, I need to send to my uh, front end. Done. Yes, so this is the logic only. So this is a like very easy code we have written. Now here you can also integrate your open source LLM. You can use PAM2, you can use Llama. Okay, you can also use Falcon, anything you can use. I think I already showed you how to use them. And you can also integrate LangChain with that. Okay, so if you're using open source LLM, so you can also use LangChain. Okay, with the help of LangChain, you can also do it. And the same thing you can do the return here. Okay, as a response. Now let's test it whether it's working or not. So I'll go back to my Chainlit, then I will refresh. Yeah, now let's say if I give any message, let's say hi, so it is received hi, because I need to, I think, restart it. So I'll uh, open my terminal and I will close the execution. If you press Ctrl C, it will close. Now let's restart again. So I have restarted. Now here is my new one. Now let's see if I give any message hi. See, it's giving hello, welcome to Zomato, how I can assist you. So here I can give my name is Bappi, uh, and I am looking for I'm looking for something. I'm looking something for dinner. I'm looking something for dinner. Okay, now it is telling, hi Bappi, I'm here to help you find something delicious for dinner. What type of cuisines you are in mood for? We have options like pizza, pasta, then Asian cuisines, then beverages and Indian cuisines. Let me know your preferred. So I will go for Indian food. Okay, now see, it is giving great choice, Bappi. Indian cuisine is always a treat, and here is some option for the Indian menu. Now it is telling butter chicken we have with naan, and even it is also giving the cost because we have added the prompt here. I think you remember. Then tikka masala rice, then palak paneer, then chana masala, vegetable biryani, samosa, lachi. So I'll give. I need this one, chicken tikka masala with rice. Okay, so I'll just write add chicken tikka masala rice in the cart. Yeah. So I have added chicken tikka masala in the cart. Is there anything else would you like to order, or this is all for you? Uh, no, it's fine. Okay, all right. Here is the summary of your order. So chicken tikka masala. Now, if you see, this is the price. Now it is telling, is that correct? And would you like to pick up your order or have it delivered? So I'll tell have it delivered. Delivered. Great. We have will deliver your order to you. Could you please provide me your delivery address? So I'll give some address here. So I'll tell my address. My address is this is my address. Let's give this address. Okay. So thanks for providing your address, Bappi. Your order will be delivered to 17th floor, Brigade Signature Tower. The total amount for your order $10.99. How would you like to make the payment? We accept cash on delivery or online payment. I'll go for cash on delivery. Cash on cash on delivery. Perfect. You can pay in cash when the delivery. Thank for the placing your order. Bapi, your chicken tikka masala with rice will be delivered shortly. If you have any other questions or need further assistance, feel free to ask. Enjoy your meal. Uh, Great. Thank you. Okay. See guys, we have implemented one amazing food delivery bot with the help of this Chainlit. And now see the interface guys. It's like very professional, very amazing, right? Very amazing. Now if you deliver this project to someone else, they will be going mad, right? Like whatever things actually you have developed, right? Now what I will do quickly, I'll just what I will do, I will just quickly commit the changes to my GitHub so that also you can get the code. So I'll just write completed commit. Done. Now if I go back to my GitHub and refresh, yeah, so you have committed. So yes guys, this was the demo of the Chainlit. I think you enjoyed this package a lot, and even I'm also enjoying this package a lot. Okay, I'm just trying to use this Chainlit package to build my LLM apps and all. And see guys, like by using some like very less line of code, actually we are able to build these kinds of awesome application, and it's like very fast, right? Now we'll try to see the deployment part, like how we can deploy these kinds of projects on the cloud platform. So I think you already know we implemented so many end-to-end projects, right? So implemented medical chatbot, then source code analysis. Then we also implemented something called Zomato chatbot, right? So different application we implemented so far. Now in this video, I'll show you how we can deploy these kinds of application on the cloud platform. That means here we'll be deploying our application on the AWS cloud. If you want to learn any other cloud deployment, it is also fine. See, the process will remain same, only the cloud functionality would be different. So I'll try to create some more video on the deployment. Like I'll also show you how we can deploy these kinds of project on the GCP cloud, on the, let's say, the Azure cloud. But first of all, let's try to see how we can deploy this project on the AWS cloud. And see, this is not going to be a simple deployment. So here we'll be doing continuous integration and continuous delivery or deployment. That means CI/CD. So I think you have heard of this particular term called CI/CD, right? So we'll be learning how we can deploy this project as a CI/CD. I think you already know how to deploy any machine learning project, deep learning project as CI/CD, but we haven't seen how we can deploy any kinds of generative AI based project as a CI/CD, right? So that's why make sure you are watching this video till the end. So here I'm going to show you each and every step you have to follow. And trust me, if you follow this step, guys, you can use this step to deploy any kinds of, let's say, generative AI based project. Okay, and this is going to be production grade deployment. Okay, so here I'm going to use different kinds of service from the AWS. Even I'll be also using Docker. That means first of all we'll be dockerizing the entire source code, then we'll be deploying this application on the cloud platform. Okay, so make sure you are watching this video till the end. So before starting the deployment, guys, first of all, let me show you what exactly we're gonna perform here. What is CI/CD exactly? Then I will also discuss, let's say, what are the tools and technology we'll be using here, what are the services we'll be using here. Then I will start with the deployment, and make sure you have the AWS account. If you don't have the AWS account, guys, so you won't be able to deploy this project. So first of all, try to create one account. If you're creating for the first time, you will get $300 free credit. Okay, and this is enough for you. So try to create an account, guys. Then you can start with the deployment with me. So let's open up our Blackboard and try to see the architecture overview. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say
somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time, then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application, then you will be uploading your updated code. Then this code will reflect to the endpoint, then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application. Yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CI/CD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called CI/CD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CI/CD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually 3 famous tools actually we are having in the market right now. So people are using more this GitHub Action, because GitHub Action you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can let's say use Jenkins, Circle CI. These are the services as well. Fine. So yes guys, this is the complete high level architecture of our deployment. Now let's discuss what are the services actually we'll be using for the deployment. See, here the first services actually I'm going to use called Docker. So I think you already know Docker. So Docker is a containerization service. So with the help of that, you can containerize your code. That means, let's say you are having a source code, you can perform the containerization. That means it will create a Docker image for you. Okay. So this image you can, let's say, keep anywhere. Let's say you can keep in the Docker Hub. You can keep, let's say, in the ECR, that means Elastic Container Registry. From there, you can pull the image and you can execute this image. Okay. So if you are using Docker, so you won't be getting any kinds of setup issue. This is the main advantage here. Then we'll be using something called ECR here. ECR means Elastic Container Registry. So this is the service from the AWS. Okay, AWS giving the service. So here you can store any kinds of Docker image. It is the same like your Docker Hub. Okay, but it is the service from the AWS. You can store the private image there, but in Docker Hub actually all the image would be public. This is the difference only. Now we'll be using another service called EC2. Okay, EC2 is a virtual machine service from the AWS. Again, it is from the AWS. Okay, so this will give you virtual machine. There you can buy, let's say, CPU based machine, GPU based machine. Okay, so all kinds of configuration would be there. So here we are using our local computer. So there we'll be getting a cloud computer. Okay, this is the difference only. Then as a CI/CD tool, I'll be using something called GitHub Action, as I already told you. Okay, we'll be using GitHub Action for the CI/CD management. Fine. So yes, guys, these are the services as of now I'm going to use. So let me show you the deployment step we'll be following. For this, what I have done, guys, I think you remember we implemented one medical chatbot. This is the code, and this code would be also available in your resources section. Even you will also get this code in my GitHub. So guys, this is my GitHub profile. Just search ENTBuppi in the Google, you will see my GitHub, and here I have created one repository called end-to-end medical chatbot. So I'm going to commit this code here, so you will get all the source code from this repository itself. Okay, and even I will also add the deployment step in the README file. So that is what actually I have written. You can see the entire deployment step I have written here. Now this is the CI/CD deployment we'll be following. So first of all, what I have to do, we have to let's say create a IAM user. Then we'll be creating the EC2 machine ECR. Okay, then we'll be, see, this is the deployment step as of now. Just try to follow the step I'm going to show you. First of all, we'll be building our so here, first of all, we'll be building the Docker image of our source code. That means Docker image will be implementing. Then we'll be pushing this Docker image to the ECR. That means Elastic Container Registry to store my Docker image. Then we'll be pulling this image from ECR in the EC2. That means we'll be pulling that image in the EC2 machine in our virtual computer. Then we'll be launching this Docker image in my EC2 machine, and from there we'll be creating an endpoint, and that endpoint user will be able to access. Okay, and these are the policy I have to give whenever I will be creating the IAM user. Fine. So this is the entire step, guys, I have written. Even I've also given all the command you need to execute here. Now let's start the deployment, guys. But before that, you just need to prepare some of the files. The first file you have to prepare the Docker file. So this file will help you to containerize entire your application. That means it will perform the Dockerization. And these are the Docker command you have to write. So I think you remember we are using Python 3.10. Okay, this Python version. That's why I have taken Python 3.10 Slim Bastard image. Then working directory, it will create a working directory called app. Inside that, it will copy all the source code. Then it will install the requirements. Okay, whatever requirements actually we are having here. Got it? Then it will execute this Python 3 app.py command. So that means my endpoint would be executed. Okay, my application would be running. And make sure before actually deployment, you just store your index. Okay, in the Pinecone. So this is the Pinecone, guys. It is running, and all the vector is already stored here. You can see 7020 actually record is already stored here. So I already executed this file. I think you remember store index. So it will create all the, let's say, vector embedding, and it will store in the Pinecone. Okay, Pinecone vector database. So in this project, I was using Pinecone. I think you remember. Okay, so this should be available here. Got it? So once it is available, now what I have to do, guys, then you can create another file called Docker Ignore. Inside Docker Ignore, you can mention like some of the file which is not required. Let's say here this file is not required. Let's say I think this file is not required. Generative AI project.eginfo. Okay, so whenever it will perform the, let's say, containerization, that means Dockerization. So I don't need this folder. That time what you can do, you can mention this folder name in the Docker Ignore file. It is the same thing as your Git Ignore. So it is already mentioned inside my Git Ignore. That's why I haven't mentioned inside my Docker Ignore. Docker Ignore is completely empty. As of now, I need all the file. That's why I haven't keep anything here. Now let's say if you want to ignore any kinds of file which is not required, that time you can store these other file inside Docker Ignore. Okay, that's the thing. Now the next things you have to create. You have to create one folder called .github. Okay, inside that you have to create one folder called workflows. Inside that you have to create one YAML file. You can give any name. Here I have given CICD.yaml. Okay, now see, this is the complete YAML file. So this YAML file will help me to do the CI/CD deployment. Okay, that means here it will be using something called GitHub Action. Okay, and GitHub Action need this YAML file. So here all the command is already written. So first of all, you will see that it will perform continuous integration. Inside continuous integration, it will authenticate with my AWS account. Okay, then it will log in with my ECR. Then whatever, let's say, Docker image actually will be building, you will push that image to the ECR. Okay, that means Elastic Container Registry. Then your continuous deployment will start. Again, it will authenticate with AWS account. Then it will pull that, let's say, image from your ECR to EC2 machine. Then it will execute it here. And here all the environment variable I have set. You can see -e means this is the environment variable. See, AWS access key, AWS secret key. I'll tell you how to generate these are the key. then a Pinecone API key, OpenAI API key, everything I have set here. Okay, so these are the thing we'll be reading from the secret. Okay, GitHub secret. I'll tell you how to create the GitHub secret as well. So as of now, just try to remember this is the YAML file you have to use for the CI/CD, and this YAML file you can use as it is. No need to change anything in your other project as well. Okay, that's the thing. Now let's open up our AWS account. So guys, this is my AWS account. I already logged in with my AWS account. So here, so first of all, what you have to do, you have to create a IAM user. So let's create a IAM user. So IAM. So the first thing we'll be creating one user here. So let's create one user. I'll create a user. So let's say username is, I'll give medical bot. You can give any name, it's up to you. So let's click on next. Now you have to give policies. Okay, like what are the policy you want to give in this user? I don't want to give my entire policy. That means all the services I don't want to give the access. So I'll be giving some specific access. So access wise, I already written in the readme file. Let me show you. So these are the access I'll be providing: my EC2 container registry full access and EC2 full access. Okay, these are the thing we'll be giving. So here just search it. So this is the ECR. Okay, ECR, Elastic Container Registry full service, here I'm giving. So let's select, and after that again I can delete it. Then I'll try to copy the next service. This is the service. Okay, this is the EC2 machine service. So again search here and select the EC2 machine and click on the next. Now you'll see that I have given this two service. Okay, next thing, just create the user. So right hand side you can see one button is there, create user. Just click on create user. So guys, as you can see, my user has created. Now I'll click on the user. Then here you will get one option, security credential. Just click here. Then you have to create a access key. So click on create access key, select command line interface, and I understand this above recommendation, and click on the next. So there is a next button, just click on the next. Now create the access key here. Now see guys, this is your access key and secret access key. Try to download as a CSV file. So let's download. So and just keep it with you. Okay, this thing I need later on. Okay, and no need to share this key with anyone, otherwise they will also access your AWS account. Okay, so here I'm showing because after the recording I'll delete everything. Got it? So my IAM creation is done. Now I'll go back to the home page. Now the next thing what I have to do, guys, I have to create a ECR repository to store my Docker image. So let's search for ECR. So just search for ECR, that means Elastic Container Registry. Just open it up and make sure you check your region, in which region you are working. See, I'm working in Mumbai, AP South 1. If you're in other region, just try to note it down. Okay, you have to note it down, this syntax actually, AP South 1, then CS Central 1. If you're, let's say, in North Virginia, you have to give US East 1. So just try to remember these are the tag. Okay, so I'm inside Mumbai, that means AP South 1. Now I'll be creating a Elastic Container Registry. So let's create, so let's click there. Now you have to give the name. Let's say I'll give medical chatbot. You can give any name, it's up to you. Everything keep it as default. Now click on next. Now see, my repo is created. Now what you have to do, just copy the URI and just try to paste it as of now here, because this thing I need later on. Just for reference, I'm saving it here. Okay. That's it. Now what I will do, I will go back again. Now the next thing I have to do, I have to create my EC2 machine. Then I have to set up, these are the requirements. Okay, that means I have to set up the Docker there. Then I will be also updating that machine. So let's create my EC2 machine right now. So search for EC2 here, EC2 instance. So this is the EC2 service. Now launch the instance. Now select the Ubuntu machine. And what you have to do, give the name of the machine. Let's say medical bot machine. You can give anything. Then see, instance type, you have to take at least 8 GB RAM. 8 GB RAM, just take 8 GB RAM. I'll be taking T2 large. Okay, this machine. And then select the key value pair. If you don't have the key value pair, you can also create it. So let's say I'll give medical. So it will create one RSA file. So guys, you can see after creating and download, it will give you one PEM file. So this PEM file you can use. Let's say if you're using any third-party tool to connect with your EC2 machine, let's say Putty or Mobile Extreme, that time you can use this PEM file. But I'm going to launch my, let's say, machine in my second tab with the help of AWS only. I don't need this PEM file. Okay. So now I'll select these two options, HTTPS and HTTP. Keep it everything as default. Configuration storage at least take, let's say, 30 GB. And launch the instance right now. So here you can see, click on view all instance. Then see, my machine is running. So if status is running, now click on the machine ID. Now here you have to connect this machine. So click on the connect button. Now I'll be selecting the EC2 connector and let's connect the machine. So it will create a new tab for me. So here I will get one terminal, black terminal. So we have to use this terminal to set up everything here. And this is the production server, guys. Okay, that's how your production server looks like. See, this is the production server. Let me zoom. Now let me clear. See, here you won't be getting any kinds of UI interface. Okay, that means the way we are using our computer, it is having UI. But in the production server, you won't be getting any kinds of UI. You have to work with the terminal always. And this is the Linux terminal I got. This is the Linux machine, guys. So that's why if you know any kinds of Linux command, it will help you a lot. Got it? So here, first of all, I have to update this machine. For this, you have to execute these at the command one by one. So let's copy all the command one by one. Okay, so this is done. Now I'll copy the next command and just try to paste here. Now give yes permission and press enter. Okay, so execution is completed. Now I have to set up the Docker in the EC2 machine. So this is the command you have to run. Copy the next one and execute. Then I will execute this one, then the last command. So we have to add the Docker in the sudo group. Okay. Now, if it is running or not, so what you can do, you can execute one command, docker ---- version. So if it is showing the version, that means Docker is installed successfully. Now, we have to set up our self-hosted runner. EC2 as our self-hosted runner. That means we have to connect our GitHub. Okay, you can see this is the GitHub. Now, this is our project GitHub. So this GitHub I have to connect with my AWS. That means whenever user will, whenever let's say developer will push the code in the GitHub, it will automatically get updated to the AWS. Okay, AWS cloud. So for this, what I have to do, I have to go to my project. Make sure you committed your repository in your GitHub and go to the settings. Okay, go to the settings. Now here, left hand side, you will see one option called action. Just click on the action, click on the runners. Now create a new self-hosted runner. Now select the Linux machine and you have to execute. These are the commands. So let's copy this command one by one and let me execute here. So it will automatically make the connection with your GitHub. Let me show you. Then the third command. Then fourth command. Now you have to go to the configuration section and copy this command and execute it here. Now see GitHub action, it will automatically connect. Now it will see it has connected to the GitHub. Now it is asking for enter the name of the runner group. I don't want to give anything, press enter. Now it is asking enter the name of the runner. So here you have to give self-hosted. Okay, self-hosted. This is the thing you have to give. If you're giving another thing, it won't be working. Okay, make sure you're giving self-hosted. Now let's press enter. Now keep it everything in default, just press enter again. Then again press enter. Now see, it is done. Now the last command we have to execute this one. And you can ignore this one, it is not required. Now see, it would be connected with my GitHub. See, connected to the GitHub, listening for the jobs. Okay. Now if I show you, if I come back and now if I go to the runners, let's say, I'll go to the runners. Now see, status should be idle. You can see it is connected. Okay. Now the next thing what I have to do, I have to set up all the GitHub secrets. Okay. Now let's go back to the secret. So secret variable, click on the action. Now new repository secret. Now give the secret ID. Okay. So for the first ID I have to give AWS access key ID. Just copy and give the key name here. And where you will get the value, I think remember we downloaded one CSV file. So let me open this CSV file. I will open in a Notepad++, and this is my AWS access key ID. I'll copy, and here let me paste it. Then the next one I have to give secret access key ID, copy, and create another new repository secret and give it here. And in the CSV file, you will get the next one. See, it is comma separated. So before the comma, this is the AWS key ID, access key ID, and after the comma, this is the secret access key ID. So let me copy the secret access key ID and I will paste it here. Okay, now the next thing you have to give AWS default region. So region, I already told you I'm inside Mumbai. That means AP South 1. So I think remember, I'm inside AP South 1. See, AP South 1, you have to write it. So let's write AP hyphen South. Okay, hyphen 1, AP South 1. Let's try to check AP South 1. AP South 1. Okay, fine. Now let me add it. Now the next thing, I have to add my ECR repo. So ECR repo wise, I think you remember we copied one URL. So just try to get this name only. Okay, after .com, just try to get the name and try to mention here. Then the next thing, I have to set my Pinecone API key. So let's copy and add it here. And I think you remember in my .env file, I had my Pinecone API key. Let's copy. And this is not available inside my GitHub. That's why I'm reading from the GitHub secret. Okay, this is the idea. Now I also need to add my OpenAI secret. Okay, that means OpenAI API key. The last one, you can see OpenAI API key. Let's add it. So let's copy the OpenAI API. Here I'm going to paste it. Now let's add the secret. Okay, now see, everything is added. Now let me see anything is left. No, everything I have added. Now what I have to do, I have to push the changes. Okay, but before that, let me get back to my project. Now I'll push the changes. So just try to commit. To commit, just open up your git bash and try to write this command, git add space dot, then git commit hyphen m, let's say ci cd added, then git push origin main. Now if I go back to my GitHub, now see, if I refresh here, so it will start running my action. Now just go to the action. Now see, my action is running. See, first of all, it is running the continuous integration. So inside continuous integration, first of all, it will authenticate with my AWS ECR, build the Docker image, push it to the ECR. Okay, everything will happen. See, automatically. It's just a one-time setup, guys. Next time, you don't need to set up it. You just need to write the code and push it to the GitHub. Automatically, it will push to the, let's say, AWS server. Okay, now see. So let's wait. Once this execution is completed, I will come back. So guys, as you can see, my continuous integration is completed. Now it is running the continuous deployment. Now what it will do, it will again authenticate with my AWS cloud, and it will pull that image from the ECR to EC2 machine. And if you go to the Elastic Container Registry right now, and if you refresh here, you will see the image. Okay, see, Docker image is been uploaded here. Now see, it is running the deployment. Now see, it is pulling the image. So once it is full, then we'll doing the port mapping. We'll create the endpoint, and we can access our application. Let me show you. So guys, as you can see, my execution is completed. That means both integration and deployment is executed. If you're not getting added, that means congratulations, it's done. Now I will go back to my EC2 machine. Okay. Now here in the EC2 machine, you will get one public IP address. Just let me show you. So this is the public IP address. Just try to copy and just try to open it. Okay. Now see, if I open it up, so it won't be opening because see, my application is running on port number 8080. I think you remember. Okay, so by default, port number 8080 is not set. So I have to do the port mapping. So what I have to do, I'll go back, go to the instance. This is my instance. Then I'll go to the security. Okay. Now here you will see one option called security group. Just click here. Now on top you will see edit inbound rules. Okay, just try to click here. Now I'll just add the rules. Custom TCP port number, just give 8080. Just select 000. Okay. And here you will see save rules. Okay, just click on the save rules. That's it. Okay, so rules has been added. Now I'll go to the instance again. I'll open it up. Now I'll copy the public IP address again, and here let me paste. Now you have to give clone port number 8080. Now see, if I hit enter, my application should be running. See guys, this is my chatbot is running. Now if I give any message, let's say what is Acme. See guys, it is giving me the response. Now see, my application is live right now. So it is already deployed. Now user can use my applications. Now what you can do, you can buy a domain, okay, your custom domain, and you can publish this application to the audience. Okay. Now for the second time, let's say you changed anything in the code. Let's say you added some more function. What you have to do, only just need to commit the changes. It will automatically get updated here. Fine. So no need to set up anything from scratch. It's just a one-time setup. Once setup is completed, just try to commit the changes. It will automatically running. Okay. Now you can ask me, if I close this terminal, will it work? Yes, definitely you can close it. Let's say I will close this terminal. Now if I again go to the chatbot, if I refresh, see, still my bot is running. Okay. So that's how, guys, we can do the CI/CD deployment. Now let me show you how we can terminate all the instance, like whatever instance we created, if you don't want to keep it running, otherwise it will charge you, right? So what I can do, first of all, I will stop the EC2 machine I've created. So select the machine, click on the instance state and terminate. So terminate will delete it. Okay. So it will terminate and delete the instance. Then after that, I also need to delete my ECR. So let's go to the ECR. So first of all, delete the image inside that. Just write the delete command. Now try to select and delete. Okay, then what I have to do, I have to delete the then I will also delete my I'm user. Okay, the I'm user I created. User. Let's select and try to delete it. Medical chatbot I have to write here. So let me copy. And let me delete it. See, everything is deleted. Now nothing will charge you. Okay. So guys, that's how we can perform the deployment. And this is the code you can use. This code as it is. Okay. The code actually have shared. So yes, guys, this is all about, and I hope you liked it. So thanks for watching, guys. And what you need to do, guys, the next project I showed you now that this one, source code analysis, you can deploy this project with the same process. Okay. Whatever project we have created so far, you can deploy with the same process. So guys, we'll be starting with another very important concept inside generative AI called LLM Ops. So I think you already heard of this name, okay, called LLM Ops. So the full form is Large Language Model Operation. So those who are from machine learning and deep learning background, I think you know there is another actually concept called ML Ops. So with the help of ML Ops, we can perform machine learning operations. That means, let's say if you want to build any kinds of end-to-end MLDL application, you can follow some certain step. Okay, there's some certain pipeline you can follow. That means you can follow some certain pipeline to implement that particular application. And here MLOps usually help you to implement that particular pipeline, right? So similar things actually we can also apply in the generative AI. So I think we saw inside generative AI, we can use different kinds of, let's say, tools and technology. Like we can use different kinds of framework. We can use commercial large language model. We can use open source large language model. Yes or no? So commercial wise, I already told you, we can use OpenAI platform, because OpenAI gives you the model with the help of API access. That means you can create an API with the help of that. You can access this model in the OpenAI platform. So for this, you don't need to download the model in your system. Okay. So download, you don't need to do. Let's say if you're using any low configuration system, still you can use that model. But whenever it comes to open source large language model, any kinds of foundation model, I think I showed you the entire Hugging Face platform there. We are having so many open source large language model, right? Let's say if you want to use this kinds of foundation model, because apart from OpenAI, these are the model are also good. Now, this is also better. Some of the model you will see it is better than OpenAI model. Okay. Now, if I want to use these are the model efficiently, if I want to create a efficient application, even if I want to deploy this particular application on the cloud platform, how we can do it? Because we saw that if I'm using this kinds of model, like open source model, I have to first of all download the model in our system. And whenever I'm downloading, you should have good configuration machine, yes or no? That means you should have good GPU, good memory, good CPU. Then you will be able to execute this model. And let's say you want to fine tune these are the model. Definitely you need a very good configuration GPU. Otherwise, you won't be able to fine tune that. I think we already saw one fine tuning example of Llama 2 model. There I was fine tuning this model on top of our custom data, and I was using Google Colab. So there actually it was taking lots of time, let's say, to train only one epoch. Just try to consider. Got it? So that's why LLM Ops comes into pictures. So LLM Ops will gives you the flexibility to work with different kinds of foundation model. Okay. Like what kinds of foundation model? I think you saw like Llama is there, Mistral is there. Okay. Gemini is there. Different large language models are available. So different foundations model are available. I already showed you in the Hugging Face platform. Okay. So if you want to use these kinds of foundation model, foundation large language model with all the flexibility, you have to use something called LLM Ops. There are some LLM ops platform are available. This will give you all kinds of flexibility. You can work with this kinds of foundation model. Even it will give you all kinds of functionality. Okay, all kinds of functionality it will provide you. All you just need to use this platform to implement your LLM powered application. I'll teach you all the platform, whatever platform actually we are having, which is like famous in the market. I'll discuss all of them one by one. Okay, no need to worry. So first of all, let's try to see why LLM ops is required, because we saw that like what is LLM ops exactly. Now we'll try to see why LLM ops is required, why we need it exactly. For this, I'm going to open up my Blackboard and there I'm going to explain this concept. So guys, I think so far you have learned about LangChain. Okay, LangChain. Then you learn about Llama Index. Okay, then you also learn about open source large language model. Okay, open source LLM. Even I also taught you the OpenAI. Okay, OpenAI. And OpenAI provides actually commercial model because all the models are paid here. If you want to use them, you have to pay for that, right? And how it will charge you based on the token limit. And this will give you the API key. Okay, API key. With the help of API key, you can access this model. But apart from that, there are so many actually foundation model. I think I already discussed inside Hugging Face. Okay, Hugging Face platform like Llama was there. Okay, then Mistral was there. Then Falcon was there. Okay, then Gemini, Jimma. Okay, and so on. There are so many models. If you open the Hugging Face platform, you'll see that there are so many models are available, and these are the foundation model. And this model is pretty good, guys. If you see this model is like very powerful model. It's very powerful model. Even I already showed you some of the demo. We created some of the application with the help of open source large language model. There, I think you saw the power of the model. Yes or no, right? But I think one issue you saw whenever I was using this open source large language model, the issue was this model size is very big. Let's say if I'm considering Llama 2, just try to consider about Llama 2. So now tell me, Llama 2 having actually how many variant? I think you know Llama 2 is having 3 variant, like 7 billion parameter model. Then it is also having 13 billion parameter variant model. It is also having 70 billion parameter model. Even recently there is another model you will see called Llama 3. Okay, Llama 3, and Llama 3 is very huge than your Llama 2. So you can open up the Hugging Face hub and there you can search for Llama 3, you will see the model. So here I already told you, if I want to use this model, actually I have to use GPU based machine, GPU based system, yes or no. And if I'm not using GPU based machine, so what will happen? I won't be able to execute this at the model. But if you see, there are so many developers, there would be so many enthusiasts, they will prefer to use this at the open source large language model. But most of them will not have the GPU based machine. Okay, because it's obvious because if you see nowadays, actually whatever laptop, whatever let's say system we usually buy, people usually take this actually GPU, let's say 3060, okay, Ti. So I can consider RTX, okay, RTX 3060 Ti. If you have actually less budget, then you can buy this GPU. If you have more budget, you can also buy higher configuration GPU. But there are very less people, they will buy the higher configuration GPU. Let's say who have the huge amount of earning, they will buy it. Okay, but if you have actually less budget, because see, majority of the person will have the less budget whenever they buy any kinds of system. So they will have, let's say, this GPU 3060 Ti. Okay, so this GPU having actually, I think around 4 to 8 GB, I think VRAM. Okay, VRAM it is having. Okay, now just try to consider, let's say I'm loading this Llama 2 7 billion parameter, okay, this model in this GPU. So what would be the inference time? As of now, let's try to consider, let's say it will take 5 minutes. Okay, 5 minutes to give you the response. Now just try to consider, if your application is taking 5 minutes to execute only one prompt, will people use your application? Tell me. If let's say I'm using ChatGPT, and if I'm giving any prompt to the ChatGPT and ChatGPT is taking, let's say, 5 minutes to give me that response, so will I use the ChatGPT again? No, definitely I will not use, because nowadays you will see that people will have very less time. They want actually quick response from any kinds of application. So what you have to do, the system you are developing, this should be very fast. Okay, the inference time would be very fast here. Otherwise, people won't be using your application, right? Then let's say you are loading this 13 billion parameter model, okay, in the RTX 3060 Ti GPU. Let's say now it is taking 10 minutes to execute. Okay, 10 minutes to execute. And after that, let's say you are taking 70 billion parameter model in the RTX 3060 Ti, and you will see that sometimes it will give you memory, okay, memory out of space, okay, out of space error, okay, because this GPU doesn't have the capacity to load this 7 billion parameter model, because I told you it is having 4 GB and 8 GB VRAM. Okay, so that time actually we are not able to use this kinds of foundation model. But let's say somehow we are using this foundation model. Let's say we are using small variant of the model, let's say 70 billion or 13 billion. But what is happening? Inference time is very high here. Okay, it is like very slow here. So again, people won't be using my application. So this is another issue. Got it? Now let's say somehow you created one application. Let's say it is taking 5 minutes to execute. Now what you have to do? If you want to publish this application to the audience, you have to deploy this project, yes or no? Let's say you want to do the deployment. You have to do the deployment. Okay, deployment. Now, I think previously I showed you one deployment, right? We deployed one end-to-end medical chatbot project. There I was using actually AWS. Okay, AWS. So I was using, let's say, EC2 service from there. EC2. Then I was using ECR. Okay, Elastic Container Registry. Then I was also using something called Docker. Okay, so these are the services actually I was using there one by one. Now, see, there I was actually deploying the OpenAI based application. That means I was using OpenAI model. That's why I was able to deploy this project in the cloud platform with the help of these are the simple service only. But whenever you are using open source large language model, so that means this model you have downloaded in your local machine. And now what you have to do, you have to move this model to the production server. That means your cloud machine. And there, just try to consider if you are using this kinds of 8 GB, let's say instance, like T2 large instance, will it work? So I think you remember we used something called T2 dot large instance there. And it was having 8 GB memory only. Okay, 8 GB memory with CPU code. So it won't be working, right? If I'm loading this Llama 3 or Llama 2 in this machine, it won't be working. So for this, what I have to do, I have to purchase actually a GPU based machine there. So if you see the EC2 instance, you will see that there actually will also have GPU based machine. So there actually you can also purchase GPU based machine. Apart from that, AWS provides another service called AWS SageMaker. Those who are from actually MLOps background, they already know what is AWS SageMaker. So SageMaker is a complete actually platform. So here you can actually ingest, okay, train, evaluate, okay, evaluate and deploy any kinds of machine learning or deep learning project. Okay, and it also provides different virtual instance. That means virtual computer. Okay, virtual, let's say computer, it will also give you. So there actually you can take any kinds of instance and you can, let's say, host your model. It is also possible. So SageMaker provides actually lots of service. You can search over the Google. You'll see that it provides different services. Okay. Now, a few months back, actually, I was going through one actually research article. So there I found if I want to, let's say, deploy any kinds of open source large language model, let's say my custom created, let's say, server. Let's say I want to launch my own server, and there I want to host my model. For this, what I can use something called SageMaker. Okay, AWS SageMaker I can use because SageMaker will give you different kinds of instance. Okay, so there actually you can host your model. And if I want to use SageMaker and if I want to, let's say, deploy this kinds of open source large language model, because see, if I want to use this kinds of open source large language model, I have to use different library. Like I told you, we have to use Hugging Face. Okay, we have to use LangChain. So different things we have to install. Even if I want to use Hugging Face, I also need to install Accelerate, Bits and Bytes, because this model access the GPU, right? And to access the GPU, I also need these are the packages. Okay, I already explained in my Hugging Face session. So if I want to install these are the packages, whenever, let's say, I'm taking any EC2 machine, there you will see installation issue. So most of the time you will see lots of installation issue actually will get. But what they did actually, they created one service called DLC. Okay, DLC, that means deep learning container. So this service is already available in the AWS. Okay, you can use with the help of SageMaker. You can use this DLC, that means deep learning container. So inside deep learning container, you can install any kinds of deep learning package. Let's say you can install Hugging Face, you can install, let's say, PyTorch, TensorFlow. So all the, let's say, library would be already pre-installed there. So you don't need to, let's say, manually put the effort to install these at the library. Okay, with the GPU configuration, everything would be already there. Okay, only just need to take the DLC, let's say, instance, and you have to connect with the SageMaker. That's the idea. Okay, so with the help of SageMaker, with the help of DLC, you can host this model. Let's say you are having one open source model. Now you can host this model in the DLC platform. Got it? And to get the, let's say, endpoint from the model, what you have to do, you have to use something called API Gateway. Okay, API Gateway. So this is another service from the AWS. With the API Gateway, what you can do, you can create an API. Okay, API. Like we saw, like OpenAI API. Now we used to use one API. So here also you can create an API. With the help of API, other people can access your model. Let's say this is a user. So user can access your model with the help of API request. So this API will request this, let's say, model. That means, let's say you are using Llama model. Okay, and Llama model is present inside DLC. That means deep learning container. It is running on the SageMaker actually instance. Okay, from there actually you can get the response. Now let's say somehow you deployed this a model like that. Okay, the way actually I showed you with the help of SageMaker, DLC, API Gateway. Okay, all the services. Let's say you deployed this model, and now let's say it is working fine. Now there one issue we'll get. The issue is cost. Okay, so it will actually charge you huge amount of money. Let me show you. So in that research article, I got one image actually. Let me show you the image. So I have already taken the screenshot. So this is the image, guys. I think this image is visible. See what they did actually. They have taken different Llama model. You can see they have taken different Llama model. Let's say Llama 2, 7B, 7B chat, 13B, 70B. Okay, and this is the model ID, and this is the max tokens. Like what would be the input length, okay, of this model? I think you know, Llama 2 takes actually 4096 token. Okay, and this is the default instance type actually they are suggesting. Let's say if I want to use Llama 2 7B model, so I have to take ml.g5.2x large machine. Okay, and this machine is available in the SageMaker platform. Now let me show you the SageMaker. So if you just search for SageMaker, okay, SageMaker pricing. Just search for SageMaker pricing in Google. So you will get one website, machine learning service, Amazon SageMaker pricing AWS. Just try to open it up. Now here, if you just go below, you will see SageMaker will give you all kinds of price list with respect to all kinds of, let's say, machine type. Let's say you want to use MLT3 medium. It is having actually 4 GB RAM, and here you will get 2 vCPU, and this is the price per hour. Like that, actually, it is having actually different instance. Actually, you can see it is also having large instance. So you can see it is also having large instance, X large instance. Okay, then 24X large also instance it is also having. Now see, the more good configuration instance you will be taking, that means your vCPU is increasing as well as the, let's say, memory is also increasing. You will see that price is also increasing. So this is the per hour price. Let's say per hour price, it will charge you $6. If you're taking ML M5D 24X large. Now see, if I show you the chart now, so this chart also they have also suggested. Let's say you are implementing one project with the help of Llama, let's say Llama 70. Okay, Llama to 70 billion parameter, and now see this is the configuration you have to take. This is the configuration you have to take. MLG5 48X large. Okay, configuration machine. But let's try to consider Llama to 13 billion. Okay, let's say you want to use this actually configuration model. Now let's find this configuration. MLG5 12X large. So here you can find out that configuration. You can see there are different series are available. This is the M5, C5. You can also find out the G5. So as of now, let's try to consider this machine. Let's say ML M5D 24X large. Okay, let's say I want to use this. Okay, this machine. I want to use this machine. This machine is having 96 actually CPU, and it is also having 384 GB memory. Now, what is the per hour cost? Per hour cost is, you can see, $6. Okay, almost $6.5. You can consider $6 as of now. Now let's calculate the pricing. So what I'll do, I will open up my calculator. I'm going to actually calculate the price per day. Actually, per day, how much actually it will charge me. Let's say the price, you can see it's $6. Okay, $6 times, I want to run 24 hours. This model, okay, this model I want to run, let's say 24 hours in my actually SageMaker, okay, platform. Because see, 24 hours your application should be keep on running. It's not like that you are running for 2 hours, again you are stopping. No, people won't be using your application. ChatGPT is running 24 hours, okay, 7 days. It is all, running every time. So you will see there is no downtime. So whenever you are creating your application, it should be always running in 24 hours. Okay. So let's say I want to consider per day how much actually it will charge me. So 24, 6 times 24. So it will charge me actually $144. Only just one day, it will charge me $144. Now, if you're from India, if you're from Bangladesh, if you're from any other country, just try to convert the currency, okay, in your, let's say, money, and try to see how much money actually it is taking per day from you. Got it? Now, let's say I want to run this model. Let's say I want to run this model, let's say 7 days. So what I'll do, I'll just multiply with 7. Now see, this is the 7-day cost I got, $1,008. So it is more than 1 lakh rupees. Okay, more than 1 lakh rupees actually it will take if you're running this model 7 days. Let's say I want to run this model 4 weeks. So this is the charge actually it will take. Now let's say I want to run this model 1 year. So I can multiply with 12. See, this is the 1 year cost actually you are getting. $48,000. Okay, 384. So now let's see, if you're running a small startup, if you're running a small company, so will you afford that much amount of money? Will you be able to pay this much amount of money? No, definitely you are not. So at the end, your cost is increasing. If you're using this kinds of open source large language model, if you're deploying on this kinds of, let's say, platform, on the custom, let's say, hosted server, so you will have lots of cost at the end. So better to use the OpenAI model that time, yes or no? Because OpenAI model will charge you less, very less than this amount of money. Got it? So that's why actually LLM ops comes into picture. So what big tech company actually did, they came up with actually different kinds of LLM ops platform. So I think you saw, not recently actually, this LLM ops platform came actually long back. So Google actually came up with one LLM ops platform called Vertex AI. Okay, Vertex AI. So previously, when you used to use ML ops, also we used to use something called Vertex AI for the ML ops also. Because this Vertex AI provides all kinds of functionality, all kinds of, let's say, pipeline for the machine learning operation as well. Okay, nowadays they also integrated generative AI, okay, in the Vertex AI. Even AWS, that means Amazon Web Service, they also came up with another LLM ops platform called Bedrock. Okay, Bedrock. Okay, Bedrock. So Bedrock is also one LLM ops platform. And this is the new service actually they have launched in the AWS, actually, let's say, website. You will see that there will be one section called Bedrock. Okay, so Bedrock also provides all kinds of LLM ops services. Let's say you want to use any kinds of foundation model. You want to use Llama, Mistral, okay, any kinds of foundation model. So this model is already hosted. See, this model they have already hosted in their server. Let's say whatever Llama model, whatever Mistral model, whatever model you see, these are the model is already hosted in this LLM ops platform. Like that, Google has also hosted lots of foundation model in their server. It's not like that they're only hosting their model. Let's say Google is having their own model. They're having Gemini model. They're having Gemma model. Yes or no? Apart from these are the model, they also hosted some of the foundation model from any other organization. Let's say from Meta AI, from, let's say, Mistral. So what they did actually, they collaborated with these are the organization. Even they hosted their model in their platform as well. And they created one endpoint. They created one API. Okay, they created one API. Now, as an user, what I can do, I can use this API to interact with this model. That means, like, our OpenAI will send the request. Okay, will send the request to this kinds of LLM ops platform with the help of API. And here I will mention what kinds of model I want to use, and this will give me the response. That means I don't need to download these are the model in my system. Okay, so this is the main benefit to use this kinds of LLM ops platform. Okay, and it is having all kinds of flexibility. Let's say you want to connect the data. You can easily connect. Let's say you want to connect the vector database. You can easily connect. Okay, that means all kinds of storage, all kinds of flexibility this LLM ops platform will provide you. It's not like that manually you have to take from any third party, let's say, tool. It's not like that. Complete, like, let's say, pipeline it is already having. Even let's say you are thinking to fine tune this kinds of foundation model, you can also fine tune. You can also perform the fine tune operation. So fine tuning will happening in their server only, not your system. Only you just need to set the configuration of the model. Then you have to pass your data. Automatically, it will perform the fine tuning in their server. Yeah, it is sure they will charge you, but you will see this price would be very less than your this cost actually, whatever cost actually I showed you here. Nah? If you're, let's say, manually creating your server, if you're using manually different kinds of services, that time price would be high. But if you're using this kinds of LLMOps platform, your price would be very low, guys. Trust me, it would be very low. If you see the pricing, now if you see the pricing, I'll tell you whenever we'll be exploring these are the LLMOps platform. There I'll also show you the pricing. You'll see the pricing, it should be very low. Correct. So that's why actually LLM ops is required. We need the LLM ops if I want to use these kinds of foundational model. It's not like that we only need to rely on the OpenAI model, because we saw that there are so many models which is more powerful than my OpenAI model. Even there is another cloud provider, I think you know, Azure. So Azure also having one LLM ops platform called Azure OpenAI. Okay, Azure OpenAI. So they have, what they did actually, they collaborated with OpenAI and they bring the OpenAI platform in the Azure platform only. Okay, on top of that, they created some more services and it is running on the Azure right now. So if you know about OpenAI now, OpenAI, so you'll be also work with the Azure. Okay, Azure, let's say OpenAI. So OpenAI wise, we already saw how we can use OpenAI with the help of OpenAI PayKey, how we can access different kinds of foundation model. Okay. So yes, guys, this is the complete idea of our LLM ops and why LLM ops is required. Okay. So in the next video, we'll be learning about one amazing actually LLM ops platform called Vertex AI from the Google side. So we'll see the entire platform, what kinds of service it provides. Even we'll also do lots of practical. We'll also do the hands-on. We'll be creating different, let's say, LLM powered application with the help of Vertex AI. Even I will also show you the AWS Bedrock, how we can use the Bedrock, okay, to implement any kinds of end-to-end LLM powered application. Even we'll also learning how we can deploy these at the project as well. Fine. In this video, we'll be starting with our very first LLM ops platform called Vertex AI. And I think I already told you Vertex AI is the platform from the Google. So it is available in the Google Cloud. So Google has developed this platform. So here we'll be doing this complete generative AI on the Google Cloud. We'll be learning how we can use different kinds of foundation model. Even with that, how we can create different kinds of LLM powered application. So guys, here you can see this is the complete revolution at the Google inside artificial intelligence. I think you remember in 2017, they bring actually one architecture called Transformer. So whenever this Transformer architecture came in the market, after that actually so many revolution happened in the field of language model, in the field of large language model. That means whatever architecture you can see nowadays, all the architecture are using this Transformer architecture in the backend. Even I already created one video, right? I already took one session on the Transformer architecture, like what was the main component inside Transformer architecture and why it is so powerful, right? So then after that, actually in 2018, actually they came up with another model called BART, B-E-R-T. So this is one of the actually language model they brought. Then they brought actually T5 model. Then slightly actually in 2020, actually they brought one large language model called LaMDA. So LaMDA was an amazing model in the field of large language model. Then 2021, they actually published AlphaFold model. Then 22 Palm model. And in 2023, they introduced something called BART model. Okay, B-A-R-D, BART. I think we used to use Google BART, right? Google BART, that means it is the ChatGPT kinds of interface, I think, remember. Nowadays, this BART has been, let's say, replaced with the Gemini. So we now actually we search for Gemini, but previously we used to search for BART, right? So this was the first application from the Google, actually they published. And you can see the model summary, like what are the tasks this model can perform. So as you can see, T5 can perform text-to-text generation. It's a transfer learning model. It is having actually 10 billion parameter and it's open source model. Then Google LaMDA model. Then you can see the LaMDA model trained to converse. Then AlphaFold predict structure for all known proteins. Then Palm, actually, this is the industry leading actually large language model. They introduced something called conversational AI, the service powered by LaMDA. Okay. Then in 2024, I think you can see from the Google research, we are having Gemini. Then Imagen 2. Okay, this can actually generate image, okay, with respect to the text prompt. Then we're having also something called Zima. Okay, Zima is one of the large language model. Then there is another model called Sharp. This is the model, it can generate speech to text. So that's how actually revolution happened. That means it took actually lots of time to came up in this position. And Google introduced actually so many research, so many model, okay, so many technology. And nowadays actually we are using this kinds of technology, okay, in the field of generative AI. And guys, here you can see these are some actually first party foundation model like Palm for text. You can customize language task. Then Palm for actually chat. So here you can perform conversation. Okay. Then you can do the image gen. Okay. For the text to image. That means if you give any, let's say, prompt, it will generate the image. Okay. Then we also had something called embeddings model, that means embedding API. Let's say you want to generate any kinds of embedding for the text or image, you can use this kinds of embedding model. Okay, then chart model, speech to text, then code generation model was also available. So this was the first party foundation model in the Google research. Okay, then they introduced something called Model Garden. Okay, so what is Model Garden? So here you can access, customize, and experiment with different foundation models and its API. Okay, that means what Google did actually, they introduced one platform called Vertex AI. So Vertex AI was the platform in the Google, and it's been actually long. This platform is available in the Google Cloud, but only we used to perform MLOps operation with the help of Vertex AI. But whenever actually this generative AI came, so they updated this Vertex AI and they introduced something called Model Garden. That means inside Vertex AI, you have one Model Garden. Inside Model Garden, you are having all kinds of Google model. Whatever model actually Google has published now, all the model you will get, all the foundation model you will get in the Model Garden. Apart from that, you will also get something called open source model. Like whatever open source model I think I showed you now, from the Hugging Face, from different let's say organization like Llama, Mistral, Falcon, right? Different kinds of open source model I think I already introduced in the Hugging Face. So what they did actually, they also hosted this kinds of open source model in the Model Garden. That means you can use all kinds of open source model from the Model Garden itself. Okay, from the Vertex AI. Then it is also having some partners model. So what is partners model exactly? So they collaborated with different kinds of organization. They collaborated with the different kinds of company. Let's say Cloud is a company. Then we are having Meta is a company. Okay, that's how we are having different kinds of company. So this company has also introduced so many large language model. Okay, so what they did actually, they collaborated with the company, collaborated with the organization, and all kinds of actually model they introduced in the Model Garden. So this is called actually partner models. Now let me show you the Vertex AI platform right now, how it looks like. You can see guys, this is the previous Vertex AI platform. Okay, that means here we used to only perform the ML operation, that means machine learning operation. That means you can perform the experiment, train, and deploy, okay, for the data science workbench. Now what they introduce actually, on top of this platform, they introduce generative AI. You can see they introduce something called generative AI platform. That means here you can perform the prompt designing, fine tuning, generative AI studio, okay, foundation model, open source model. Okay, then you can also perform actually LLM ops, everything you can perform in this platform right now. That means instead of replacing the previous actually, let's say Vertex AI services, on top of that, they created one additional layer, and this is called actually LLM ops platform. Now it is on the Vertex AI. Okay, now I think it is clear. Now, as I already told you, they introduced so many actually partners model. Okay, I already told you they introduced so many partners model in the Model Garden. So these are the partners. Okay, these are the partners actually with Google. I think nowadays they also collaborated with so many organizations. If you open the Google Cloud Vertex AI, will see different kinds of actually partner models are available. So here you can see AI21 Labs. These are another organizations that they collaborated with the Google. Then Anthropic, Cohere, then Contextual AI, okay, Midjourney, then OSM-MO, then Resistant.ai, Meta, okay, Runway, and so on. So these are the actually partners model actually you'll be getting in the Model Garden. Now let me show you this GCP, okay, GCP Vertex AI. So let's open up our account and let's open up the Vertex AI there and try to see whether these are the things are available or not. So for these guys, what you can do, just search for GCP, okay, GCP console in your Google, and make sure you have one GCP account. Okay, if you don't have the GCP account, guys, so you won't be able to use the Vertex AI. So make sure if you don't have the account, just try to create one account. Initially, it will give you $300 credit. Okay, so let me log in with my console. So guys, as you can see, this is my GCP console. So here, what you have to do, in the search button, just search for Vertex AI. Okay, Vertex AI. So you'll see this is the platform. This is the LLM ops platform you will get. See, this is the complete Vertex AI. Now, left hand side, you will see different kinds of services. So here, I already told you it is having Model Garden. So let me click on the Model Garden. So here, you will see all kinds of model. So guys, as you can see, whatever model I showed you, all kinds of model are available. Apart from that, they have also actually brought new model here. You can see. So foundation model, okay, then partners model. See, all kinds of models are available. Okay, as you can see, Meta model is available. That means Llama 2, Llama 3. Okay, then Palm model. You can also show all the model here. See here, I can click on the show all model. See, all kinds of model are available. See, Mistral also is there. Then Jamba model. Then you can see Cloudy. Okay. Apart from that, you will see different kinds of actually foundation model you will get. Okay. And these are the actually partner, okay, partner company. Apart from that, you can also filter out. Let's say you need language model. So here you are having 63 language model. You can filter out all the language model. Let's say you need vision model. You are having 11 vision model. You can also filter out all the vision model. Okay. Now let's say you want to use this model. Just click here. And you will get all the guideline how to use this model and all. Okay, they have already given the source code, everything they have given. Okay, how to use the Python SDK for let's say using this model and all the let's say guideline they have already given. Okay, I'll tell you how we can use these are the model one by one. Okay, now let's say you want to also play this model in the model garden. Okay, it is also possible. Let me show you. So let's say this is my model garden. Let's say I want to let's say play with this model Gemini 1.5 Pro. So I'll just click here. Now you can see open in a Vertex AI Studio. So here you can open this model in the AI Studio. So they are also having one AI Studio. Let me show you. Even you can also open with the help of Colab Notebook, and there also you can also play with this model. Now let's click on the I agree and continue. Now here you can pass any kinds of prompt. Let's say I will give hello, and I will send this prompt. And this is the response actually I'm getting. Okay, so that's how actually you can play with different kinds of model before using it, like how this model is working on all, what is the performance of the model, everything you can perform here. Okay, then you can also search by the model name. Let's say you need Jima model, Llama model, anything you can search here. You will also get these are the model. Got it? And guys, these are the model is already hosted in the Google Cloud, so you don't need to manually download these are the model in your system. You can use these are the model with the help of API request. As I already told you, that's how. So that is why we call it as a LLM of platform. Okay, so they give the API kinds of functionality with the help of API request. We can use these are the model in our let's say project implementation. And don't you worry, I'll tell you how we can access different kinds of model. We'll be also implementing some kinds of application. Now, apart from that, Vertex AI also provides so many services. You can see it provides the pipeline services. This is the pipeline for the ML ops. Let's say you want to perform any end-to-end pipeline, data ingestion, data validation, model training, model evaluation, you can use the pipeline services. Apart from that, it also provides the notebook services. That means, let's say you want to, let's say use one large language model. You want to fine tune one large language model, you can use their Colab Enterprise. That means you can take the machine, okay, good configuration machine, good configuration Colab Notebook in their Google Cloud service. Okay. Then you can also take the Workbench as well. Then you can see different studio is there. You can perform different kinds of, let's say, task demo. Let's say you can perform chat demo, vision demo, translation, speech. Okay, you can play with these are the functionality. As of now, I'm not showing. Then you can also download different kinds of extension for the generative AI from the extension market. Here you will also get something called feature store dataset. Okay, labeling task, then training, experiment. Okay, so some of the services you will see these are the MLOps services, not the generative AI services. Apart from that, you will also get something called vector search here. This is another super important service from the Vertex AI. Let's say you don't want to use any other vector database. What you can do, you can use this Vertex AI vector search. This is another vector database. Okay, and this is hosted in the Google Cloud. That means in the Vertex AI. So going forward, I will also show you how we can use this vector search. Okay, vector search functionality from the Vertex AI itself. So yes, guys, these are the services actually Vertex AI provides. So unless and until you are not exploring all the functionality, okay, you won't be getting. So try to open this account, guys, and try to explore all kinds of functionality. Okay. And now there I told you can perform different kinds of operation. Okay, different kinds of this operation. It will give you all kinds of functionality. Okay, and I showed you the model garden and all. So then I already told you we can also perform something called fine tuning. So it's not like that you can only use these are the foundation model for the inference. No, you can also perform the fine tuning operation. That means this Vertex AI will give you the functionality. You can also improve the model performance with the help of fine tuning. Okay, on top of your custom data. You can also perform something called human feedback to increase your model usefulness. Like I think previously you saw in the ChatGPT, it used to give one feedback box, right? Let's say how is your experience. So that you can give your experience rating. So that kinds of rating also you can pass if you're using this kinds of Vertex AI. Then here you can also generate customized images for your business. Then here you can also improve Google's predictive AI with your own custom data. Okay, everything is possible here. Now you can ask me what kinds of tasks actually I can perform here. You can perform all kinds of tasks. So you can perform language, image, video, okay, documents, speech, tabular. So here all kinds of tasks you can perform with the help of Vertex AI. Okay. And what Vertex AI actually provides, as I already told you, it will give you state-of-the-art foundation model. Even you will also get end-to-end governance. That means you can do the prompting, tuning. Okay. You can also perform MLOps operation on the Vertex AI. Even here you will get the data privacy. So whenever, let's say you are uploading your custom data to the Vertex AI, it's not like that your data would be leaked. It would be secure. Okay. So this kinds of actually ensured you will get if you're using a Vertex AI platform. That means you will have the complete data security. So no need to worry about your data if you're having any custom data. All the data would be secured here. So now I think you got the difference between MLOps and LLMOps. So in the Vertex AI, we have the MLOps like services already. On top of that, they created the LLMOps. Okay. So here we don't need to throw out your existing MLOps investment. Okay. So here what you need to do, you just need to understand the unique MLOps need for the generative AI. That means whatever additional, let's say, functionality they have given, just try to understand and try to use, let's say those are the service in the generative AI field. Okay. That means you can see in the Vertex AI, you will see multitask model prompting. Okay. Then model garden, customization, managing new artifacts, evaluation monitoring. Okay. Connecting with the enterprise data. Let's say you want to connect with different kinds of data sources. It is also possible in the Vertex AI. So now as a high level, you can see the complete MLOps on the Vertex AI. This was actually our traditional Vertex AI. That means here we can perform experiment, training and deploy and predict, okay, for the machine learning operation. And now in the Vertex AI, you can also perform something called prompt predict. Okay, then you can also use something called foundation model. That means all kinds of generative AI based functionality you will get here. Then I already told you, you can also connect with different enterprise data. Let's say you want to connect any external sources, any API, any website, you can also connect, okay, with the help of Vertex AI. So guys, all kinds of flexibility you will get here if you're using Vertex AI LLMOps platform. So no need to worry about anything. So yes, guys, this is the complete introduction of our Vertex AI, the complete generative AI on the GCP cloud. In the next video, we'll try to see how we can build different kinds of transformative LLM powered application, okay, with the help of this Vertex AI platform. So far, we have discussed about LLMOps and this generative AI Vertex AI. Now in this video, we'll be trying to use this Vertex AI as a practical. That means, let's say if I want to use any kinds of foundation model with the help of Python code, so how we can do it. Okay, that means we'll be doing the entire hands-on in this video. So try to open up your Google Cloud, guys, everyone, and just try to open up your Vertex AI. I already showed you how we can open up the Vertex AI, right? Now, after opening the Vertex AI, the first thing you have to do, you have to enable all the recommended APIs. So there you will see one option, enable all the recommended APIs. So make sure you have already enabled all the recommended APIs. So after enabling, in the notification bar, you will see all the API has been enabled. So these are the API you should enable. Otherwise, sometimes actually will get actually different error. So that's why make sure you enable all the API. Now here you can either open up your Google Colab to perform all the, let's say, operation I'll be doing here. Either you can also open up this Colab Enterprise or Workbench. Okay, so here I'm using this cloud platform, that means LLMOps platform. So in this video, I'll show you how we can use their services actually. Let's say if I want to use Colab Enterprise, how we can use Colab Enterprise. You can also launch this Workbench. So what is the difference between Workbench and Colab Enterprise? Let me show you. So in Workbench, actually, you can select the machine configuration. So here you can create a new Workbench. Just try to click on create. Now here you can select the machine configuration, like what should be the machine name, what is the reason. Then you can also select the instance type. Okay, that's how actually you can change the configuration. Okay, all the configurations you can change here. Okay, everything you can change here. That means if you want to create a custom machine as per your requirement, you can change here. And here you can see the pricing summary. That means per hour, it will charge you $0.18. You can see price is very less. It's not like a very huge amount of money they will be charging. It's like very less money. So you can also create your custom configuration. But here I'm not going to create the custom configuration. What I'll do, I'll use the Colab Enterprise. Okay, this one. So it will give me Google Colab kinds of interface. And there I can actually do my coding. So after clicking on Colab Enterprise, so here you will get one option, create a notebook. Okay, so just create a notebook. You can also select the region, but I will keep the default region, US Central 1. Okay, that's it. Now you can give the name. I can rename this notebook. Let's say I'll rename it as Vertex AI Demo. Okay, you can give any name. I've given this name. Now, if you want to increase the size of the notebook, if you want to increase the size of the cell, let's say if I write something, so the text is like very small here. So I can also increase the size. So for this, what I can do, I can click on the settings. Just go to the editor. And here you'll see this font size. Just try to make it as, I can take 28. Okay, 28, I think it is fine. Now, the next thing what you have to do, guys, you have to connect this notebook. So let's click on the connect button. See guys, once you will be connecting the notebook, it will give you this kinds of pop-up screen. That means you have to select an account, okay, like which account you want to use. So make sure whatever actually account you are using for the Google Cloud Console, that means for the Vertex AI, that account you have to select here. So this is my Google Cloud account. I'll just try to select. Now it is also asking for password. So let me give my password and I'll click on next. So if you're doing for the first time, so it will give you this kinds of authentication. It's just a one-time authentication. Okay, that's it. So guys, as you can see, my runtime is connected. Now if I execute the cell, if you want to execute the cell, just press shift and enter. The same thing, the way actually you execute any Colab notebook, you can execute as the same. Now see, I'm getting the okay output. Now you can also download this notebook. So there is a download button. You can also download the notebook. So first of all, let's do the coding. After that, you can also download this notebook. Even I will also share this notebook with you in the resources section. Fine. All right. Now see here, we'll be using actually Vertex AI. Okay, we'll be using Vertex AI services. That means we'll be using Model Garden. So from the Model Garden itself, what we'll do, we'll try to access different kinds of foundation model. Got it? And if I want to use Model Garden, that means the complete Vertex AI, I have to install one library. So you have to install Vertex AI SDK for Python, because we'll be using Python code, right? And if you're using Python code, you have to install this library. So here I want to install the upgraded version of the package, and this is the package name, Google Cloud AI Platform. Got it? If you want to use Vertex AI, you have to install this Python package. Now let me install. Okay, now after installing, it will tell you restart the runtime. Just click here. So it will automatically restart the runtime. After that, you just need to import Vertex AI. Okay, just to test whether everything is fine or not. Now see, if I import, it should work. See, it's working fine. There is no error. Fine. Now see, those who are running this code from the Colab notebook, you just need to do two configuration here. So let me show you. So the first configuration you have to do, this one. That means you have to authenticate with the Google Cloud first of all. So here, let me write the code. So first of all, you have to authenticate with the Google Cloud. Okay, from the Colab notebook. And for this, you have to execute this line of code. So here, everything I'm running from the Vertex AI only. That means I'm using Colab Enterprise from the Vertex AI. I don't need to perform the authentication. But if you're running from the Google Colab, that time you have to do the authentication, guys. Okay. So let me show you one example. Let's say if I want to load any model from the Colab Enterprise, that means if I'm using Vertex AI services, I don't need to authenticate it. I can easily load it. Let me show you. So for this, let's import some of the library first. So here I'm importing some of the library. You can see generation config, generative model. Okay. I'll tell you why I'm importing them and what is the use of it. First of all, let me import all of them. Now let's say I want to load one model. Let's say I want to load this Gemini 1.0 Pro model. So you can see there is a model, Gemini 1.0 Pro. Just click here. If I click here, you will see the model ID. You just need to copy the model ID from here. Now if you just go below, they have already given the source code. Here you can see this is the model ID. Just try to copy this ID and try to paste it here. Okay, that's it. Now see, if I execute this code, it will automatically load the model. See, there is no error. But if you executing from the Colab notebook, you will see you will get one error. That means your notebook is not authenticated with the Google Cloud. Okay, so that's why you have to execute this line of code. It will what it will do, it will authenticate. First of all, it will ask for the email address. That means which email address you are using for the Google Cloud account. That email address you have to select first of all. Got it? Then the next actually configuration code you have to run, this one. Let me show you. This one. If you are using Colab Enterprise, guys, you don't need to execute. But if you are using Google Colab, you have to execute. Now see, this is the code you have to execute. So here you have to pass the project ID as well as your location. Okay, that means region. Now how you will get the project ID? So here you can see on top you have the project ID. Just try to click here. Now see, I'm inside my first project. So here is the project ID. Just try to copy the project ID and try to mention it here. Okay, in the in this box actually, you just need to paste it here. Then you have to give the region name. And what is your region name? You can see I'm inside US Central 1. So try to mention US Central 1 here. Okay. Then if you execute, it will automatically initialize with the Vertex AI. That means it will authenticate with the Vertex AI with your configuration. Now it will get to know, okay, now you are the correct user. So once it is authenticated, then you will be able to use all the services from the Vertex AI. That is all the foundation model, all the services you can use. Got it? So these two lines actually you have to execute if you are using Google Colab. See, Colab only. And if you're using Colab Enterprise, no need to execute, guys. Okay, you can run as it is. I hope it is clear now. Okay, so now I think you saw how we can load the model. To load the model, you have to use one function called generative model. You can see I've already imported this generative model from the Vertex AI preview.generative AI models. Now import generative model. Inside that, you just need to give the model ID. Now, if you want to use any other model, simply just try to open. Let's say you want to use 1.5 Pro model. So just click here. Okay, so you can see Gemini 1.5 Pro model. Now just try to go below. And here is the model ID. So try to copy the model ID. So this is the model ID. Just try to copy and try to paste it here. So that's how, if you want to use any model from the model guardian, just try to copy the model ID and try to paste it inside this function. It will automatically load that model for you. So now let's test this model. So here I'm going to pass one prompt. So here I've already prepared one prompt. Let me show you. This is the prompt, guys, I have prepared. Okay, see. So here I'm using the model object and I'm calling one function called generate underscore content. Inside that I'm passing the prompt. Why is sky? So here is the prompt. Why is the sky blue? And stream is equal to true. Why I've given stream is equal to true? Because if I show you, if I, let's say, open the Gemini or chat GPT, if you can open anything. Let's say if I give this same prompt here now. So if I, let's say, pass the same prompt, why is the sky blue? Any kinds of prompt if you give, it will give you stream kinds of output. See, it's not actually one shot output. It will give you stream output. So I think here you saw it will give you stream output. That means after one word, it is coming another word. Okay, that's how it is giving stream output, not in one shot. So that's how we also want to get the output from my response. Okay, that's why I've given this parameter stream is equal to true. That means it will give you stream output. Got it? Now see, if I execute, so here you will get one response object. See, this is the object. Okay. So it would be an object. See, this is a generator object. Now here I can apply any kinds of iterator, that means looping, and I can get the response. Now let me show you. So here you can apply looping. So here I'm applying looping for response in the responses, and I just wanted to print the text. Okay, whatever text actually I'm having from the response, I want to print it. Now see, if I execute the for loop right now, you will see the response. See, this is the response actually I got, and this response is actually short response. That's why you didn't saw the streaming output. But if it is generating bigger output, you will see the streaming output would be visible. Got it? Now we can try with different prompt. Let's try with another prompt. So I'll give another prompt here. Let's say I'll give what are the latest developments in the automotive industry. Okay, now if I execute, so it should give me the response. Okay, see, this is the streaming response I'm getting, guys. I think you saw. Okay, this is called actually streaming response. See, the complete response I got. Great. Now see, here I pass the prompt directly, okay, in the generate content function. But if you want to pass as a parameter, you can also do it. For this, I've created another example. So this is the example, guys. Just a minute. Just see that. So here I created a variable called prompt, and inside that I've written the prompt. Let's say this is my complete prompt. Create a numbered list of the 10 items. Each item in the list should be a trend in the tech industry. Each trend should be a less than 5 words. Okay, try. Now you can give any kinds of prompt. Now here what I'm doing, I'm calling the model object generate content. Inside that I'm giving the prompt. Okay, whatever prompt actually I've defined, stream is equal to true. Then again I'm performing the looping operation. Now see, if I execute, it should give me the output. Okay. Now you can also customize the prompt. Let's say here I can give translate in Hindi. See, I'm also getting the Hindi translation as well. Got it? So that's how you can also customize your prompt. It's up to you. Now, I think you remember whenever I was like going through the model guardian. So I can also open this model in a Vertex AI Studio. I think I showed you. So let's open this model in the Vertex AI Studio. See, if you open the Vertex AI Studio, right hand side, you can see, you can also set some of the model parameter like temperature, output token. Okay. So these are the things you can also change. So how we can change with the help of Python code? Because as a developer, we have to use with the help of Python code, not from the UI interface. Got it? From the UI interface also you can use the model, but as a developer, we have to use from the Python SDK. So here we can also set the model configuration. So let me show you. So for this, you have to use this function actually. So I think you remembered the generation config. Okay. So let me show you. So I already prepared. See, inside generation config, I'm passing all the parameter. Okay, let me the temperature, top P, top K, candidate, okay, max output, and so on. And I think you already know these are the parameter I already explained previously. What is temperature? What is top P, top K? Got it? Here, temperature means here you are assigning the model creativity, like how much creativity you want from the model. If it is close to 1, that means it will take risk. It will be more creative. If it is close to 0, it won't be taking any kinds of risk. Okay, that's the idea. Now this generation config you have to pass as a parameter of generation config. Here you can see generation config is equal to generation config, and the same prompt I have given, stream is equal to true. Again, I'm looping through the response. Now if I show you, now I'll see that your output would be more creative. Okay. So previously, I think you remember we got actually very short output. Now see, this output is more creative right now because we given the configuration model parameter right now. Okay, I hope it is clear. Now let me show you another thing you can do. This is called actually test chat prompt. Now, what is test chat prompts? Let me show you one example. Let's say here I ask one question, why is the sky blue? Okay. Now, this prompt actually I have given, and my Gemini will try to remember this prompt. Now, if I ask, give me the answer in bullet point. Okay. Now see, here I haven't mentioned I want this answer. I just give me the answer in bullet point. It will automatically remember my previous, let's say, context. Okay. That means I want to ask this particular response. Now see, it has given me in the bullet point. Okay. So this is called actually memory. That means it is trying to remember the chat history. So that thing you can also perform here. So let me show you. So for this, you have to use one more line here. This is the line, guys. Model.start chat. So this start chat will automatically remember all the conversation you are doing with your large language model. Now this is the prompt actually I have given. My name is Bappi. You are my personal assistant. My favorite movies are The Lord of Rings and Hobbit. Suggest another movie I might like. So this is the prompt I'm giving, and this is the stream is equal to true I'm giving. And now see, if you're using chat, that time you have to use chat.send message. Okay, chat.send message, because here you have initialized the model. I think you remember. Now see, if I execute the program. So guys, as you can see, I got the output. Okay. Now what I will do, based on this answer, I will ask another question. So because it has remembered my previous context. So here now asking, are my favorite movies based on a book series? This is what actually I'm asking. Now see, if I ask this question, see, it will refer my previous actually context. Yeah, you can see both the Lord of Rings and the Hobbit trilogies are the based on the book series. Okay, by J.R.R. Tolkien. Okay, now I can show you the story. So if you want to see the story, just write chat.history. So it will show you the entire story. See, so first of all, you ask this prompt, your model has given this answer. Then again, you ask this question, your model has given this answer. Got it? I hope it is clear. Fine. So that's how actually we can use any kinds of language model. Now let's try to see any multi-model. That means we'll be also using some vision model. So I think you know, here actually we are also having some vision model as well. So this is my model garden. Now just click on the vision model. You will see there are different kinds of vision model are available. So from here, I'm going to use one vision model. So Gemini 1 Pro vision model. So you can search this model here. Now, if you want to load this model, you can load like that. This is the model ID. So let me show you this model. I'll copy the name, and in the model garden. So here you can search this model. You will see Gemini 1.0 Pro vision model. Okay. Now see, this is the vision model. So with this model, actually, you can also work with the images and videos. Okay. Now this is the model ID you have to give. Now I've given the model ID. Now let's load the model. Fine. Now here I'll be working with images and videos, and to work with images, videos, I need some helper function. That means this helper function will help me to load the image, visualize the image. Okay. So here I have created some helper function. Let me show you. So these are the helper function I created. You can see different helper function I created. Display image. So it will display the image. If you want to get any image as a bytes from the URL, you can get with the help of this function. Load image from the URL, you can use this function. Get URL from the GCS, you can use this function. Print multi-model prompt. That means if you want to print any multi-model prompt, you can use this function. Okay, so that's how we can create some utility related function, and this function you will get over the internet. If you just simply search how to display image, give me a function, you will get this kinds of code. Okay, so I have initialized, these are the utility related function as of now. Okay, so here the first thing I'm going to show you how to generate actually caption from any image. Okay, so for this, let's see one example. This is the example, guys. So here I'm downloading one image. You can see this is the image URL. So guys, you can see this is the image. Okay, this image actually will be downloading. So here, let me show you. And how we are downloading the image, we are using gsutil command. Okay, so if you execute this command, it will download the image from the URL. Then I'm loading the image. Then I'm giving a prompt, describe this image. Okay, I'm passing the image as well as the prompt. Then I'm using the multi-model. That means the model we have loaded, I think, remember this Gemini 1.0 Pro vision model. Okay, you can also use any other vision model. So simply go to the model garden and try to choose any other vision model. You can use as it is. Okay, now let's get back. Now whatever actually, let's say output I'm getting, I'm just rendering. Okay, that's it. Now let me show you. So guys, as you can see, this is my results I got. So here I've given a prompt and this is the image. Now it has given me the caption. So the image shown a gray cat with black strips walking in the snow. The cat has yellow eyes and long tail. You can see yellow eyes and long tail. Cat is walking towards the camera. Okay, that means this is a great caption my model has given me. Now let me show you another example. So I prepared another example. So guys, you can see I'm using another image. Now if I show you this example, see, this is my prompt. I have given describe the image. That means describe the scene. Now see, this is the response I got. Now this is the response to pontoon boats are anchored in the Charles River in Boston. In the background are two breeze and Boston skyline. So guys, as you can see, this is a correct caption my model has given me. Okay. Now if you want to use load image function, that means the function we created in the utility function to load this image URL, you can use this load image URL function as well. And with the help of that, we can also do the same thing. Okay, there are different technique you can load the image. You can also use OpenCV to load the image. Okay, it's completely fine. Now see, I'm getting the same output. Now here we'll be learning another thing. Here we'll be combining multiple image and text prompt for the few shot prompting. That means here I'll be passing the few shot to my model, and my model will try to give me the response. So let me show you one example I prepared. So this is the example, guys. So here I'm using 3 images. So let me open all the images. So this is stored in the Google Cloud storage. Okay, you can see this is another image. So you can see this is one of the images, this is another image, and this is another image. So these 3 images actually I'm using here, and with the help of load image from URL, I'm loading both 3 images. Then first of all, I'm giving the prompt for 2 images. You can see these 2 images I'm giving the prompt. This one and this one. This one I'm not giving any kinds of prompt. Okay, you can see I've given city is equal to London, because you can see this is a London city and the landmark is a Big Ben. Okay, it's a Big Ben. So you can search on Google Big Ben, I think. Yeah, see, this is the Big Ben. Okay, so that's why I'm giving some prompting. That means I'm giving the label. Okay, now prompt 2, the second image I'm giving, this is the Paris city. City is equal to Paris, and landmark, you can see it's Eiffel Tower. Okay, you can see it's Eiffel Tower. And the third image, I'm not giving any kinds of prompt. Now let's try to see my model is able to generate the actual, let's say, prompt for that particular image or not. So here you can see I'm passing my image 1, prompt 1, image 2, prompt 2, and I'm only giving the image 3 here, not the prompt. Now I'm using the multi-model and generate content. Now let's try to see whether it is able to identify that image or not. See, these 2 actually I have given, it's fine. Now see, third one, city, Rome, landmark, Colosseum. Okay, so let me copy and let me try to verify. See, correct. It's the correct one. Okay, so beautifully my model is able to generate the response. So this is called actually few shot prompting. Now also let's try to see some video example. So what I will do, I'll download one video. So this is the URL of the video. I'll download this video. Let me download and let me show you here. So I think you remember Google has launched one phone actually called Pixel. Okay, you can see this is the Pixel. This is the Pixel advertisement. You can see this is the Pixel advertisement. Okay, so this video actually I have downloaded from the URL. Now I will give this video to my multi-model and I will give some prompt. Let me show you. So I already prepared one prompt. This is the prompt. Answer the following questions using the video only. What is the profession of the main person? What are the main features of the phone highlighted? Which city was this recorded in? Provide the answer in a JSON format. Now see, if I give this video and if I pass it to my multi-model, it should give me the response. See guys, I got the response. Now you can see the person name is Sheikha Shimada. Profession is a photographer. Brand is Google. Phone brand is Google. Model is Pixel 8. And you can see the features: video boost, night sight, city Tokyo, country Japan. Amazing. Okay, amazing actually response I got. Now you can use any kinds of video. You can do the caption generation. Got it? So that's how guys you can export different kinds of model in the model garden. It's not like only Google model. You can also, let's say, use Meta model as well. Let's say you want to use Llama model. Just simply click on the Llama and try to open this notebook. So they have already given all the code example and everything. Okay, only just you need to execute and you have to see how we can access the Llama model and all. Got it? So just try to explore guys. This is up to you because all the model I can't show you. So I have just given the demo like how we can access different kinds of foundation model. Now you'll be exporting whatever model actually you need later on. Got it? Okay. And one thing guys, after implementing all the code, what you can do, you can download this notebook, and after that you can delete this instance. Okay, no need to keep on running, just try to delete the instance. Other you can also stop the instance, but I will try to delete it. Okay, I'll just try to do the confirmation. So after some times, actually, you'll see that this notebook would be deleted. Okay, now see, this is deleted. So yes, this is the actually hands-on part of this Vertex AI. So in the next video, we'll try to see how we can do the setup, everything on our, let's say, local machine. That means how we can connect this Vertex AI with the help of local machine. That means we'll be coding everything in our VS Code. From the VS Code itself, we'll try to access the Vertex AI model. That means foundation model. Okay, so we'll try to access the model garden from the VS Code. So for this, whatever setup actually required, I'll tell you each and everything to see how we can use this Vertex AI from our local machine. That means we'll be doing the setup, everything in our local. So previously I showed you how we can use Collab Enterprise. That means everything I was performing in the G Cloud. But in this video, I'll try to use my VS Code. And to access this Vertex AI, what are the configuration we have to perform? We'll be learning each and everything. Because see, going forward, whenever you will be implementing projects, right, end-to-end projects, so you have to implement through the VS Code, right? And if you want to implement through the VS Code, you have to know how to configure this Vertex AI in your local machine. Okay, so that's why it's super important to know how we can set up everything in our local machine itself. So for these guys, you need one tool actually. So the tool name is GCP CLI. Okay, GCP CLI install. Just search GCP CLI install on the Google. So after searching this GCP CLI install, if you just go below, you'll see this link actually. Install the G Cloud CLI. So just try to open it up. Now here you will get the installer. See, download the installer. So I'll click on the link. So it will automatically start downloading this CLI for me. See, it has downloaded. Okay. And if you're using any other operating system, let's say Linux, then Debian, Red Hat, CentOS, macOS. Okay. All the command is already written here. You can follow the command and you can install this G Cloud CLI in your system. Because see, with the help of this G Cloud CLI, we'll be doing the authentication with our account. Okay, that is the thing. Now I have already downloaded it. Now what you have to do, just double click and try to install. So the way actually you install any kinds of normal software, you have to follow the same step. Okay, there is nothing new. So for me, I already installed. See, after installing, just search for Google. So you'll see this Google Cloud SDK shell. Just try to open it up. So we'll see these kinds of window. Okay, if you are getting this kinds of window, that means you have installed successfully. Okay, now let me close it. Now what I will do, guys, I will open up my local folder, and here I'm going to open up my terminal. You can open up your any kinds of terminal, whether your Anaconda terminal, Git Bash terminal, anything. Now let's also open up my VS Code here. All right, so here the first thing what you have to do, guys, you have to create one virtual environment. After that, you have to install all the required packages. Okay, then after that we'll be writing our actually code, okay, with the help of Vertex AI. So to create the environment, you can execute this command. So conda create -n, let's say Vertex AI demo Python is equal to, let's say I'll take 3.10 -y. Now let's create the environment. Okay, it's done. Now let's clear. Before clearing, I have to activate the environment. So this is the command. Let's try to copy and try to execute it here. Now let's create a file called requirement.txt. So I'll just create this file, requirements.txt. Inside that, I will mention all the requirements I need. So these are the requirements, guys, I need. I think you remember. So I think you remember, to use the Vertex AI, we have to install this package, Google Cloud AI Platform. I think in the Collab Enterprise also we did the same thing. Then Streamlit I want to use because I want to create a simple user interface. There actually you can give a prompt and you can get the response, and python.env because I'm going to manage my GCP credential. Okay, that's why. Now here, let me create this file as well. So .env. Okay, inside .env, you need actually your project ID. Okay, then you need region. I'll tell you how to collect this project ID and region, but before that, let's do the configuration, okay, with our G Cloud. So first of all, let's me install all the requirements. So I'll just write pip install -r requirement.txt. All right, so installation is completed. Now let's do the configuration with our G Cloud. So for this, you have to execute this command called G Cloud init. Okay, just try to execute this command, guys. So if I execute this command, you will see that. See, if you're doing it for the first time, you will get this kinds of window. You must log in to continue. Would you like to log in? I'll give yes. So guys, now here you have to select the account. The account actually you are using for your G-Cloud account. So this is my account. I'll select. Now you have to provide the password. So this is my password and I'll try to do the next operation. Okay, and then click on the continue and allow. Okay, now you can see I'm done with the authentication. Now if I come back, see, now actually I'm getting my project ID. You can see I'm getting my project ID. Got it? So let me show you. If I go to my dashboard, now if I click here, this is my project ID. Studios loader 4361. I think you can see that. Studio loader 4361 and 2. Okay, so this is my project ID. Yeah. Now, if you already have one existing project, you can select it. Either you can create a new project. So for me, I already have the projects. I'll just select the one. I'll select the one. That means my existing project. Now it is asking for, do you want to configure a default compute region and zone? I'll give yes. Now it is telling which region you actually want to take. So what I will do, I'll take this region actually. So Central US. So let's say I will take this one, US Central 1C. So I'll give 7 here. Okay, now I think it is done. Now let me clear my terminal. Okay, so everything is set. Now let's create one file here called main.py. Inside that, I'm going to write all of the code. Okay, that means we'll be trying to access one. That means here we'll be trying to access one model from the model garden. But before that, you have to set this env. So you have to give the project ID. So here is the project ID, guys. I think I showed you how to get the project ID. This is the project ID. Just try to copy. And here, try to mention it. Then you have to give the region. So I think region I already showed you. So here you can check the region. Click on the Collab Enterprise. Left hand side, you can see US-Central 1. Just try to select it. US-Central 1. Okay. Now just try to verify it. US-Central 1. Okay. So it's fine. Now let me save. Now let's create the main.py. So first of all, let's import all the necessary library. Yeah, so these are the library I need, guys. I think remember I was also importing them in my Collab Enterprise. So Vertex AI, then Streamlit I need for the user interface. Then I'm also importing some of the necessary, let's say, function from the Vertex AI preview generative models. Okay, so I need generation config and generative model, and .env I need because I want to load this env file. Now let's select my current environment. So this is my environment. Okay, now this arrow will be disappear. Now the first thing, I'll load my project ID as well as the region from my environment. Okay, for this code snippet you have to run. Got it? Then I'll be initializing. Then I'll be authenticating with my Vertex AI. So this is the authentication code, guys. Vertex AI.init. You have to give the project ID as well as the project location. That's it. Now let's load the model. So here I'm going to load one model from the model garden called Gemini 1.0 Pro. So let me show you. If I go to the model garden. So this is the model, guys, I'm trying to load. Just click here and you will see the model ID. So just try to copy the model ID and you can use it. So this is the model ID, guys, here. Just try to copy and mention it here. Okay, that's it. Then I've created a simple function. Let me show you. So this is the function I created. Inside that, what I'm doing, I'm just first of all creating my Streamlit title. First of all, I'm setting my page configuration like Vertex AI demo. So it will give you one name. Then I'm setting the header. That means what will happen? It will give you one title. So here you can give any name. So here I've given, let's say, Gemini on Vertex AI, or you can give Vertex AI local demo, because everything we're doing in the local machine. Okay. Then user will give one question. So that's why I've taken a text input box, and this question actually I'm passing to my model. You can see. Okay, if there is a question, it will execute this model. Otherwise, it won't be executing. Okay. After that, actually, I'm going through the response and I'm printing in my console. Okay. That means in my Streamlit console. That's it. Now, if I want to execute, I have to call the function as well. So let's call the function. That's it. Now let's try to execute and try to see whether it's working or not. So I'll write Streamlit run app.py. Sorry, main.py. I think it's. Now let's give the allow permission. So this is the interface, guys. Now here you can ask anything. Let's say I'll give hello. Let's see. You can also see the terminal to get the log. Okay, you can see it is giving me one error. It is telling Google authentication default credential, your default credential were not found. To set the default configuration, you can visit this link. So let's open this link. And I think it will suggest me some command there. So let's copy this command. And now I'll execute from my terminal. I'll stop it. Now let's execute. I'll select my account. The account actually I'm using for my G-Cloud. So I'll give my password. Next. So if you're doing for the first time, so you might get this kinds of issue. So once this setup is done, you can use it as it is. Okay, now I think it is done. Now let's execute the application again. Now let's give hello. Okay guys, now see, I got the output. There is no issue. That means what you have to do, you have to set the credential as a default credential. So that's why we actually executed this command, G-Cloud auth application default login. Got it? Now see, I'm getting the output. Now here you can pass any kinds of prompt. So here I can give, let's say, tell me about Python. Okay, see, I'm getting the entire response. Okay, got it. So you can now ask any kinds of question. That means from our local machine itself, now we are able to access the model garden. That means by Vertex AI services. All right. Okay, great. So yes, guys, this is all about from this video. Now we'll be using this technique going forward whenever we'll be implementing any kinds of project. Okay. So in the next video, we'll try to see how we can implement a RAG-based application. Okay, with the help of actually Vertex AI platform. And we'll be using some Vertex AI services there. All right. So as of now, we saw how we can use model garden. That means how we can access different kinds of model. On top of that, how we can perform the inference. But let's say if you have some custom data, and with the help of that custom data, you want to create a knowledge base and you want to connect your large language model there. Okay, and you want to perform the query operation on top of it. So how we can perform it. And this is called actually RAG. I think I already explained, okay, in my previous video. So if you're not sure about the RAG, guys, first of all, check those videos. Then you will be able to understand, okay, what I'm trying to implement here. So that means, let's say here I'll be using my custom data, and with that custom data, what I will do, I will create a knowledge base. Okay. And I'll just try to connect my large language model there. Then I'll be performing the query operation on top of my data. The data actually I have uploaded. This is the thing we'll be implementing. And here technology wise actually we'll be using the Vertex AI, entire Vertex AI platform. That means here everything will be using Google Cloud services. Okay. We are not going to use any third-party services. That means to store our data, we'll be using Google Cloud Bucket. And to store our embedding, we'll be using Vector Store. Okay, Vector Store service from the Vertex AI. This is one of the vector database they have created. Okay, this is called actually Vector Store. So we'll be using all the Google Cloud service only, not any other service. Okay, in this video. So for this, guys, you can see I prepared one notebook in the Colab Enterprise. So first of all, try to connect the notebook. After that, you can check with the help of OK command. And if it is giving the OK message, that means notebook is running. Then the first thing what you have to do, we have to install. These are the library. As I have told you, we'll be using some custom data. I'm going to use PDF document. That's why I'm installing this PyPDF2. Okay, this library. Then Google Cloud AI platform, because if I want to use the Vertex AI, I need to install this package. Then I already told you we'll be using custom data. That means custom document. And to store this custom document, I'll be using Google Cloud Bucket. I think you know Google Cloud also provides bucket service. Let me show you. So if you just open Google Cloud and search for bucket. So this is the bucket. So here you can create different bucket, and inside a bucket you can store the data. See, I already created one bucket called start content 2024. Inside that I'm having one documents. I'll tell you how to upload this document here. As of now, just try to consider we'll be using this bucket services to store my content. Okay, and no need to create manually, it will automatically create. I have already written the code for it. So these are the packages you have to install. For me, I already installed everything, so I'm not going to install again. Now see, you have to import. These are the library right now. So here I'm importing stories from google.cloud, because I told you we'll be using bucket, and to install bucket I need this actually function. Then I'm also importing text embedding model from the Vertex AI language model, because here we have to perform the embedding generation, and to generate the embedding I need some embedding model, and here I'm going to use Google embedding model. Okay, from the Vertex AI, from the model garden. That's why I have imported this text embedding model function. Then I also imported AI platform PyPDF, and these are the library I also imported here. And here I'm using UIID. Okay, why I'm using UIID? Let me tell you. See, there is a reason actually I'm using UIID. See, if you're using Vertex AI, this rag would be slightly different. Okay, slightly different. That means, let's say whatever documents you will be publishing, let's say I will be publishing one statistics PDF I'm having. Let me show you the statistics PDF. So guys, as you can see, this is the statistics PDF actually I'm having. So this particular data actually I'll be using as my custom data. Now what will happen? First of all, I have to extract the documents from the PDF, yes or no. So after extracting, what I will get different documents. I think you know, I'll get different documents. That means doc1, okay, then doc2, and so on. Now what will happen? This document I have to convert to embeddings as well. That means it would be converted to embeddings. So let's say you will get some vector here. Let's say 0.29, 0.55, 0.88, and so on. Let's say this is the vector representation of this doc1 and doc2, and so on. Let's say I'll just create some dummy vector here. Now here what I want to do, with the help of this UID, I want to assign some unique ID. Let's say the document one it has extracted, I will assign one unique ID. Let's say this is the unique ID. Let's say 1210. Let's say this is the unique ID. Okay, it has assigned to the doc1. Then in the doc2 it will assign another unique ID. Let's say 1211. Okay. Now what will happen? This unique ID also would be assigned in the vector, because this vector is representing this documentation, yes or no. Okay, that's why this ID would be there, 1210. Then this ID would be also there because this vector is representing this document. So 1211. Now what will happen? Let's say whenever you will perform the similarity search operation, that time what happens actually, it will return the relevant answer, yes or no. I think you know, whenever you implement any kinds of RAG, whenever you perform similarity operation, it will give you some relevant answer. Okay, relevant answer you will get. Okay, and from where you will get the relevant answer? From the documents only you will get the relevant answer, the documents you are having. Okay, now let's say it will give you this relevant answer. Let's say doc1. Whenever it will give you doc1 relevant answer, that means it will return the vector, because your model will only return the numbers, not the text. Okay, and this particular number will map where? In this document. That means this document is representing this vector. That means whenever your model is generating this vector, that means it will map this documents, that means the text. Okay, how? With the help of this UID. Okay, with the help of this UID. So it will look for where this UID is present, that documents actually it will show you as a relevant answer. Okay, now I think it is clear why I'm using this UID to give to assign actually unique ID in front of my documents and in front of my vector embeddings. Okay, now I think it is clear. Now let me clear my board. Now the next thing what you have to do, guys, you have to initialize some of the variable. Now see, if you are doing this project from the Google Colab, first of all you have to authenticate with your G Cloud. And now to authenticate, I already shared you two code. I think you remember two configuration code I shared with you in my Vertex AI demo session. So you can refer the notebook and you can first of all authenticate with your Google Cloud. Okay, until you are not doing the authentication, it won't be working. I'm running from my Colab Enterprise, that's why I don't need to do the authentication. So if you're running from the Colab, Google Colab, so you have to activate this line actually, project. So you have to give the project ID here. How to collect the project ID? This is the project ID. Got it? So here I'm running from the Colab Enterprise, so I don't need this variable. I'll just try to comment it out. So here what I need the location, and this is my location. Then PDF path. So where you have to upload the PDF. So in the files actually you have to upload the PDF. Let me show you. So here you can right click and upload and try to select the PDF. Whatever PDF you are having, just try to open it here. It will automatically upload here. See, for me, I've already uploaded, and these two files would be generated as of now. See, I already executed this project. Okay, that's why all the artifacts you can see. Okay, but for you, it would be empty initially. So this two file would be created. How it will be created, I'll tell you. As of now, just try to consider we have uploaded this statistics.pdf file. Got it? Then you have to give the bucket name. So you can give any kinds of bucket name and make sure this bucket name should be unique. So this bucket would be created automatically in the bucket section. See, it is already created for me. Again, this would be created automatically. You don't need to create it manually. Then here you have to give embed file path. What is embed file path? Because see, I already told you, first of all, we have to extract the documents from my PDF. Then what we have to do, we have to generate the embedding as well with respect to the documents. And these documents and this embedding, I'm going to save in a JSON file. Okay, that's why I'm just creating some JSON file. You can see these two JSON file I'm creating. Okay, starts embedding .json and start sentence.json. Inside sentence.json, it will store all the documents, that is the English text, and inside embedding, it will store all the your embedding. Okay, embedding of the sentence. That means whatever, let's say documents you are having, that means whatever documents you have, okay, with respect to that, it will store the embeddings as well. Okay, with the unique ID. So that is the thing. Then you have to give the index name. Index name means let's say here we'll be using vector search now, and inside vector search we just create an index. The way actually we used to create the Pinecone index, I think, remember, we create an index here. So this is the index name. It will automatically create that index. Now here I've written a function. This function will extract the sentence from the PDF. So it will take the PDF path and it will give you the sentences. That means all the documents it will give you. Then I have written some of the helper function, guys. You can see generate text embedding. That means this function will generate the text embedding. It will take the sentence and it will generate a text embedding with the help of text embedding model. You can see I'm using text embedding Gecko model. So this is the model, guys, text embedding Gecko 001. So this model is available in the model garden in Vertex AI. Got it? Then I have written another function, generate and save embedding. That means this function will actually add the unique ID in front of your sentence. That means documents, and in front of your embeddings. That means vector embeddings. Okay. That means it will generate this both file. Okay, and it will save as a JSON file. You can see here I'm doing it. I'm first of all actually creating my embedding. Okay, and I'm adding the unique ID. I'm also creating the sentence. I'm adding the unique ID. Then I'm saving in a JSON file. Okay, this is the thing actually we are doing. That means this function is responsible for creating these two files, and it will store your sentences, and it will store your documents as well as the embedding with the unique ID. Okay, that's it. Then there is another function I created called upload file. That means after let's say generating this file, I have to upload this start sentence.json in the bucket. And how I will push to the bucket, we will be using this function upload file. You can see if you go to the bucket section, so this file is already present. Okay, so if you want to push any kinds of file, you can use this function. That means we created some helper function. This helper function will help me to do certain operation. This is the thing. Now here another function I have written called create vector index. So this function will create the vector index in the vector source. Okay, in the vector source vector database, and each of the dimension would be 784. I think you remember previously we used sentence transformer actually embedding model, and we used to create, I think, 384 vector representation. I think you remember, right? But if you are using this text Gecko model from the model garden, your vector dimension would be 768. This is the dimension, and you can see with the help of AI platform actually library, we are creating the index. So this function will automatically create the index for you. Got it? Then after that, I'm calling these are the function. You can see first of all I'm calling generate and save the vector. I'm giving my PDF path, sentence file path, as well as the embedding file path. Then I'm also uploading this file to my bucket. That means if I execute this line, what will happen? It will create this two file. First of all, let me open it. So this is my sentence. That means this is my document, and you can see first of all it will show you the unique ID. Then it will show you the sentence. Okay, that means this is the document it has extracted from the PDF. With respect to that, it has also saved the embeddings as well. Let me show you. So this is the embedding, and here you'll see the unique ID. That means the same ID, and now this is the embedding representation. Okay, I hope now it is clear. Now, so once it is executed, then upload file will execute, and it will upload this sentence.json to my bucket. Now if I show you, see bucket would be created, and inside bucket actually you will see this start sentence.json would be present. Okay, because later on whenever I'll perform the, let's say, similarity search operation, I need that file. I need to download that file. With that I will do the search operation. Okay, similarity search operation. That is the thing. Now the next thing what we'll be doing, we'll be creating the vector index. That means we'll be creating the index, and inside index actually will be storing all of my vector. Okay, so here you can see I'm giving the bucket name. That means from the bucket name it will load this file. Okay, it will load this file. That means the sentence file. So sentence file it will load. Then it will also take the index name, and with the help of actually that embedding model, it will generate the embeddings of that documents. The documents actually we are having, and it will store to the vector database. That means inside my vector source. Now if I execute this line, okay, if I execute this line, it will take some time. It will, that means it will process all the data and it will store to the vector embedding. After that, if you open it up, let me show you. So if you open it up, so you'll see that it will create an index. The name actually you have given start index. Okay, now you can see both places you are getting this green tick icon. That means everything is executed successfully. If you are getting any red icon, it's not completed. Okay, that means there are some issue. Now if I click on the deployed index, you'll see one ID here. So we need this ID later on. So guys, you can see this is the ID. The last number you can see, this is the ID. So we need this ID later on. Okay, see, this is the ID. This ID actually we need later on. So now let's get back to my Colab. Now again, just import some of the necessary library. Then again, set these are the actually variable like your location, sentence file path, and index name. That means the same index name. Okay, same index name you have to give. Start index. Okay, that's it. Then just load the model, large language model here. So here I'm using Gemini Pro. You can also load any other model. Then just try to load the index. That means index endpoint you have to load. And to load the index endpoint, you just need to give this ID. And how you'll get the ID, guys, I already told you. So this is the ID. Just try to copy this ID and just try to paste it here. Now if you execute, it will load the index ID. Got it? That means this is going to be your knowledge base right now. And this is going to be your model. Now again, I have written some of the helper functions, generate text embedding. That means whatever user will give the prompt. Now let's say I have given one prompt. This prompt should be also converted to the embedding. Okay, then this function will help me to do that. Then I've written another function, generate context and load file. That means it will load that documents file and it will generate the context. Okay, that means if you are performing similarity search operation, it will give you some rank results, and how it will give the rank results with the help of these two function, it will give the rank results. Now here I've loaded the file. Then you can see. Then this is my query. Let's say what is correlation. First of all, I'm generating the query embedding with the help of that embedding model. And if you want to see the query embedding, see this is the vector representation, guys. This is the entire query embedding. Now let me comment it. Now this query embedding I will pass to my vector source. Okay, now you can see find neighbor. It will give me 10 rank results. Okay, 10 rank results actually it will give me. Then this response actually I'm giving to my model. Okay, this is the code snippet. My model will try to analyze this response, even the query I have given. Based on that, it will give me one response. Now if I execute, see, if I execute this last line of code, see here you will get the response. Correlation is a statistical measure that indicates see blah blah. I'm getting the output, and here you can also give the prompt based on the context delimited in the brackets, answer the query. Okay, that's how you can give any kinds of prompt, and that's how actually we can build retrieval augmented generation kinds of application. Okay, with the help of Vertex AI platform. And all these steps, guys, I have mentioned here. So if you are implementing any kinds of RAG based actually application, you can follow the same step. Okay, even you can also perform in your local machine. That means I told you how we can connect our local machine. That means how we can connect our VS Code. So with the help of VS Code also, you can create this kinds of RAG application, and you can create a user interface. Let's say you want to create a Flask interface, you want to create a Streamlit interface, you can also create. So this task actually I want to assign you. Just try to create one user interface. So you have to use the same logic, only you just need to integrate one user interface. That is the idea. Okay, I hope it is clear. Now see, once it is done, now if you want to terminate all the instance, what you can do. So first of all, just try to delete this. So first of all, just try to delete the bucket. To delete the bucket, just try to select the bucket, and there is a delete button you will see. Just try to click on delete, and delete confirmation you have to give. So it will delete the bucket. Then you also need to delete the index. So to delete the index, just go to the index, vector search. So first of all, you have to do the yarn deploy. Then you can delete it right now, I think. Now there is a delete button. Just try to click on delete. So it would be deleted. Okay, so that's how you can remove all the instance you will be creating. Okay, so I think, guys, this is helpful. I showed you the entire like process how we can implement RAG AI. See, I think you already saw how we can set up everything in our local machine. That means if I want to connect with my Vertex AI, so what are the setup actually I can perform. So setup wise, I already covered in my previous video, so you can check it out. So here actually I've already prepared everything, because see, most of the code are similar, whatever things we implemented previously. So make sure first of all you configured everything, your account, then your, let's say, configuration, everything you just prepared. After that, in the env file, just try to change this project ID and region. So let me copy my project ID. So just try to click here. So this is my project ID, guys. Just try to copy, and let's mention it here. Okay, and region, I'm inside US Central 1 only, and you don't need to change it. Now the next thing, you have to create an environment. How to create the environment, I already told you. Okay, I'm using the same environment, Vertex AI demo. Now you have to install the requirement. So one more requirement I've added called Flask. So let me install the Flask, because in this project I'm going to use Flask. Okay, Flask framework to create the front-end application. So for this, just write this command, pip install -add requirement.txt. Now it should install the requirements. So guys, many people were asking me how to install actually GPU, NVIDIA GPU in our local system. For this, what I did actually, I created one video in my YouTube channel. Let me show you. So if you go to my YouTube channel, guys, this is my YouTube channel. You can also subscribe me here. Now, if I go to the video section, so here I already created one video. Here you can see the video, set up NVIDIA GPU. Okay, so here I showed you all these steps you can follow to set up your NVIDIA GPU for the deep learning task. Got it? So let's say if you're having good GPU and if you want to, let's say, execute open source or language model in your local machine instead of using Colab, you can refer this video that time. And make sure guys you subscribe to this channel, because here also I create lots of content related generative AI, ML ops, then end-to-end project implementation, okay, computer vision, everything. Now let's get back. So I think installation is completed. Yeah. Now see what I have done. I created one template file, and inside that this is my HTML code, because you already know if I want to use Flask, I need a HTML, okay, HTML code to create my front end part. And again, I used a Bootstrap website to prepare this front end. I'll tell you whenever I'll execute how it will look like. Now, this is my endpoint app.py, and here I've imported all the necessary library. And these code are common. I think you know we are doing the authentication with my Vertex AI. Now, this is the route I created. This route is my default route. It will launch my index.html page, and this is my prediction route. That means whenever user will give any query, okay, user input, I'm getting the user input, and this input actually I'm passing to my model, and whatever response actually I'm getting, I'm showing in my Flask server. That's it. Now let me execute the application. So what I will do, I'll run this application in the port number 8080. Save it. Now I'll open up my terminal and let's execute Python app.py. Okay, so it is running. Now let's get back. Localhost. Now see, this is how your user interface will look like. Now you can give any command. Now here you can give any query. So I'll ask what is Python. Now send a request. You can also see the log in the terminal. See, I got the response. So this is the complete response I got, guys. Got it? This is the complete response I got. Now if you want to ask another query, just try to refresh. Again, you can pass that query. Okay. Now that's how actually what you can do. The previous RAG application we implemented with the help of Vertex AI, you can create your custom RAG. That means you can use your custom documents, like we did one project, like I think remember medical chatbot. So that's how you can use your custom documents, and you can create this kinds of application. And this is the front end you can use as it is. Got it? All the HTML code I will share with you. So yes guys, that's how we can also create LLM powered application with the help of Vertex AI. So as I already told you, in the model garden, you are having so many foundation model. And if you want to fine tune, these are the model. So what are the steps you have to follow? In this video, I'll tell you each and everything. So I think remember previously, whenever we used to do the fine tuning operation, first of all, we had to download that model in our system. Then I was preparing the data. Then I was fine tuning these are the model. But here, if you're using these kinds of LLM ops platform, you don't need to download these are the model in your system. So here, what you have to do, you have to use that model endpoint. That means you will be accessing this model through the API, right? That means, first of all, you have to authenticate with the Vertex AI. I think I already told you how to authenticate with the Vertex AI. After that, just give the model ID, which model you want to use. It will automatically hit that model. So here, the only thing you have to do, you have to prepare your data. After that, all the thing would be happening in their server only. Okay. Now, let me tell you the step actually you can follow to perform the fine tuning operation. So for this, what I will do, guys, I will use the Colab notebook. So I'll open up Colab notebook. You can also use Colab Enterprise. You can also do it from your local machine. It's completely fine. But as of now, we have explored like VS Code. We have also explored like Colab Enterprise. Now let's try to see how we can also use the Colab. Okay, like our Google Colab. So here, let me change my account. So let's say I'm going to use this account. Okay, this account actually I'm going to use. And make sure the account actually you are using for the G Cloud, the same account you have to use in the Google Colab as well. Okay, otherwise you might get some authentication issue. Now what I will do, guys, I'll just create a new notebook here. So let me create a new notebook. Now simply just connect this notebook. And in between, let me show you the fine tuning step you have to follow. So see, you can follow this blog actually. So this is from actually Google. So Google developer. So they have already given all these steps actually you have to follow to perform the fine tuning operation. So I already prepared all these steps you have to follow to perform the fine tuning. Only I will show you one thing from this blog actually, the data format. Okay, so here let me show you the preparation and loading the data. See, if you are fine tuning on the Vertex AI, you have to prepare your data in the JSON-L format. Okay, see this is the JSON-L format data you can see. So here they have already given one example. Let me open up. So you can see this is the train JSON-L format data, and it is present inside this GitHub. So what you can do from this GitHub actually, see this is the data. You can download this data. Okay, in your system you can download this data. So I've already downloaded. Let me show you. So this is the data. I'll open it with the Notepad++. Now if you open the data, guys, you will see it's a JSON. Okay, JSON structure. That means you will have one key here called input text, and this is the input text, and this is the BBC data, guys. Okay, BBC news data. So in the input text actually they are having the entire news, and they're having another actually key here. Let me show you, or I can perform the Control F operation. Now here I will just write output underscore text. Now if I find it, now see guys, this is the output text. Okay, so inside output text actually what they are having the summary. Okay, summary of that news. So this is the data. Actually, that's how actually you have to also prepare your data. If you're having any custom data, what you can do, you can prepare your data with respect to that. That means what I'm trying to say, that means in the JSON file, actually, the first key will have the input. Okay, input underscore text. Okay, inside input text, what you will have? You will have the entire story. Okay, entire story. And you will have another actually key called output text. Sorry, output text. Okay, so inside output text, you will have the summary. Okay, summary of the entire story. So this is going to be your data format. Okay, that's how actually you can take as much as record you can. Got it? I hope now it is clear, the format. So whatever data actually we are having, try to convert in a JSONL format. And how to convert in a JSONL format? There are so many converters you will see inside Python. Simply you can execute those converters. It will automatically convert your data in a JSONL format. Got it? That is the idea. Now you can ask me, sir, where I will get these kinds of data? I think I already told you now. So you can use Hugging Face Hub actually. So there actually will have like so many kinds of data set. So you can use any kinds of data from the Hugging Face Hub. You can download it and you can convert to the JSONL format. And if you are using your custom data that time, you have to convert everything in a JSONL format. Okay, this is the idea. Okay, you can see the image also. They have already given the data format. So first of all, you have to take the input text. This is the entire BBC news you can see, and this is the output text. That means this is the summary of that story. Okay, this should be your data format. Now, apart from that, they have already given all the steps you can follow. So I've already prepared one notebook. Let me show you what are the things you have to do. Now, let me also add this link in the notebook so that you will have the reference later on. So this is the link I have added. Now here, the first thing you have to install some of the library. So here I'm going to install Google Cloud AI Platform because I want to access the Vertex AI, then datasets, then Google Cloud Pipeline components. Okay, these are the library I have to install one by one. Let me install. So after installing these are the library, you have to restart the kernel. And if you want to restart the kernel, you can use this code snippet actually. See, you can also do it from the UI. Just click on the runtime, restart the runtime. So there is a restart runtime option. Okay, restart the session. Otherwise, you can also execute this line of code. It will also restart your runtime. Okay, now what you have to do, you have to authenticate with your G Cloud account. For this, you can execute this line of code. So here I'm using actually Google Authenticator. With the help of Google Authenticator, actually I will authenticate with my account. Got it? So now let me execute. So it will look for your account. So it will give you one pop-up screen. Let's give the allow permission. Select your account. Let's say I want to use this account because this is my Google account. Now I'll try to select it. Now you have to provide the password. So guys, as you can see, my authentication is completed. There is no error. That means you are successfully authenticated with your this one, your G Cloud account. Fine. All right. Now the next thing, you have to select the project. So to select the project, you have to execute this line of code. So let me select the project. So I think you know how to select the project. Click here, copy the project ID, and just try to mention it here. And with this, actually, we'll be initializing our Vertex AI. So let me initialize my Vertex AI. Then let's say set some actually variable. That means my region and the project ID. Again, I'll give the same project ID. Now I have to set one configuration here. For this, you have to execute this line of code. Okay, you have to execute this command: gcloud config set project. This is the project ID. Okay, the project ID actually I'm having here. Now let me set. Fine. Now let's import some necessary library. So guys, you can see I'm importing some necessary library. Now you can ask me from where actually I got this code. If you go to that blog actually, so they are suggesting install and import. See, they're also importing. These are the library. Okay, so just try to read this blog. Actually, we'll see all the steps actually they have written. I'm following the same thing only. Now let me import all of the library. Okay, so I have imported all the library. Now the next thing, I will load my data. So let's upload my data. Either you can upload in the G Cloud bucket. So from the bucket also you can download the data. If you're having, let's say, huge data, that time you can keep in the bucket. I think I told you. So it is already having one bucket service as well. So you can also open up the bucket. Inside that you can store any kinds of data, and you can also load it here. Okay, so if I show you the bucket, so this is the bucket, guys. So here my data size is not used, so what I will do, I'll directly upload here. So I'll just upload. This is the data. Now with the help of pandas, actually I'm going to load my data. So now we can copy the path and you can paste it here. Now let's execute. Okay, see, this is the data I have loaded. Now you can see this is the input text and this is the output text. Now if you want to see the shape of the data, you can also see this is the shape of the data. And now we can start the training, and it's like very easy. See, only you just need to execute this line of code. Your training would be started in their server only. Okay, not in my Google Colab actually. It will use their instance. Got it? Now see, here is my fine-tune model name. So this model name actually I'm giving BBC fine-tune model. You can give any name. So after fine-tuning, what would be your model name? Okay, that is what you have to give here. Then you can give the pre-tuned model. That means which model you want to fine-tune. Here I want to fine-tune text Biston 002 model. And if you go to the model garden, you will see this particular model. And if you want to use any other model, you can also give the model ID here. Got it? That's the thing. Now you have to pass the data, that is by df. The df actually I got. And you have to set the number of epoch, training epoch you want to, let's say, train. So here I mentioned 100 epoch. Okay, I want to train as of now. And you have to give the tuning job location. Okay, so I have given Europe West 4. You can keep the default size. If you go to the blog, you will see that they are also using this particular location. Now see, if I execute the program, it will give me one URL. And if I click on the URL, I can see the pipeline. That is completely, that means I can see the complete pipeline. My training process is running. And it will take, guys, like 1 to 2 hours to complete the training, but I can't wait 1 to 2 hours. What I will do, I'll stop the execution. So guys, I stop the execution because it will take time. See, I'm telling you after actually executing this line of code, what you have to do. So you can see one URL. Just try to open up the URL. So this is the URL, guys, and try to make sure you have selected your account. Okay, that GCP account. Then you can see this pipeline. Okay, this pipeline would be running, and this is the jobs. So here you will see all the, let's say, logs. So in the pipeline section, you will see all the logs. That means whether your training is running or not. Okay, and how much time actually it will take to complete. So everything, all the log actually you can see here. Got it? So once this execution is completed, you will see it will automatically stop. After that, your model would be ready. Okay, and then you can use this model. And if you want to delete this pipeline, so what you have to do, guys? So there is a delete button. Just try to click on the delete and try to delete the pipeline. Okay, it will automatically delete the instance. Okay, and guys, one thing, after completing the training, if you open up your bucket, you will see 2 bucket would be automatically created. Okay, and inside this bucket actually it will save all the model checkpoints. Okay, let's say whatever training it is doing, all the artifacts would be saved inside this bucket itself. Okay, you can see. But once you complete the execution, see, it will already save the tuned model. Okay, inside that you can see the text Biston model. Got it? So that's how actually it will save all the artifacts in the bucket. And from this bucket itself, we have to deploy our model as an endpoint. Okay, and this model would be available in your model garden. So if you click on the model garden, so there you will see one option. So here is the option, my view my endpoint and model. If you click here, you will see that model would be present here. Okay, I hope it is clear. Now let me show you the next step you have to perform. So previously I already did this actually fine tuning. So let me show you what you have to do after that. See, after that actually what you can do, you can use your trained model. That means the model actually you have trained, and you can do the inference operation. So here I'm giving this prompt actually summarize this text to generate a title. So this is the entire actually prompt I'm giving, and this is the output actually I'm getting. Got it? Now you have to deploy your model as an endpoint. For this you have to execute this line of code. Okay, so this will deploy your model as an endpoint, okay, to the GCP server. That means this model would be available in your model garden right now. So if I go to the model garden, so here you will see one option, view my endpoint and model. Just click here. In this section actually will see your model would be published. Okay, from here actually it will load the model. But what I did actually, I deleted the model because again I'm using cloud platform. I don't want to keep anything. Okay, otherwise it will charge me. So that's why I already deleted. Okay, then after that I was loading that model and I was again performing the prediction. You can see this is the result actually I'm getting from my model. Then I was also loading the base model, that means the actual model, and I given the same actually prompt, and I was just checking the actually output. Okay, whether this output and this output actually good or not. That means which model is giving the better output. And here you can see both model giving the good response. Okay, it's not a bad, although I only trained 100 epoch, but you can see this response is pretty good. Got it? So that's how actually you can perform the fine tuning operation. After that you can deploy your model as an endpoint to the G Cloud. Okay, now I think it is clear. Now you can pick up any other model and you can perform the same fine tuning operation. All right, so these resources would be